carbohydrate digestibility. So in the same study, we also evaluated fecal quality indirectly by measuring the amount of feces that could be collected via settling. And for that, we used some settling columns, individual ones, which were attached for each tank. And there only the heavier and bigger particles were able to be trapped. And what we see here is that even though some diets produced a higher amount of feces, that did not correspond necessarily to producing a higher amount of settleable feces. And a great example is actually shrimp shell meal that you can see in this column here, which even though it did not produce the highest amount of feces, still the settling ones composed the highest fraction among all the diets. And we want to examine actually what kind of properties cause this kind of fecal quality in the case of shrimp shell meal. And what we saw here is that dietary starch is the one that has an impact that determines the impact on fecal quality. So the more starch you include in the diet, the more the smaller the fecal particles, or the more prone to disintegration fecal particles you get out of it. Here we saw again that the NSP amount did not really affect the fecal removal efficiency and their fecal quality, but it's still possible that the type of NSP can also explain further some differences that we saw here. And commercially, we've seen like different fibers being used for stabilization of the feces. And on the top right side, you can see an example, which is gum. It's quite commonly used and very successfully in the aquafit industry. And in this kind of line, we could also expect that the chitin, which is a fibrous structure in the exoskeleton of the shrimp, might also act as a stabilizing agent, as a binder for feces in our feces. So to summarize a bit of findings, we can say that dietary composition affects fecal composition, that dietary non-starch polysaccharides determine predominantly the amount of feces produced, and lastly, that starch affects fecal quality by producing less settleable feces. So what does this mean from a system perspective, which is actually also the focus of my research? So aquatic species can be reared in different types of systems. And here I only brought two examples that are a bit more applicable for shrimp aquaculture. In general, waste production and also waste management is like of more relevance when we talk about systems that have either stagnant waters or high water retention, or you can reuse water through a circulation loop. And a bifloc system is actually quite a representative one when we talk about high water retention systems. I'm not going to go through these because I think I'm going to step in the toes of Mark, and this is really not my expertise. The thing that I just want to say is, like, through this technology, you can actually manage in a quite successful way the waste and get rid of both the carbon, which is excreted in the form of feces, but also the nitrogen, which in this case is incorporated as growth in the microbes that develop in the system. And I'm going to mostly focus on recirculating systems, which is something that I am also more familiar with. So in RAS, we have a bit of a different approach, because in this case, we actually want to have clear water. And that is because nitrogen excretions from fish are actually converted through a process which is called eutrophication, which is performed by autotrophic bacteria that don't do very well with high organic carbon conditions in the water. And there have been several studies previously where under high organic conditions, it has been observed that nitrification rates actually go lower. And in our research, we also produced a couple of studies, and then we tried to see if that is indeed the case. And what we observed when we had trials lasting 2 months is that even though there is indeed a trend which shows that under indeed high organic carbon conditions, the removal rate of nitrogen goes a bit lower. This trend was not actually significant between the treatment groups that we had. However, we can anticipate that if we had prolonged experimental trials or the feeding log was higher, this could have been actually something like a significant difference between our treatment groups. Yeah. And that was all I had for you today.
Very good, thank you, Elisa. The next person I want to invite here is Mr. Suprapto, if I say it correctly. Mr. Suprapto is actually an alumnus of fact of animal husbandry, but after his studies has worked a lot at shrimp farms. And currently is a manager of technical support for shrimp in Dutch, Indonesia. And he's gonna give a talk about shrimp farming strategy.
Okay. Good morning, sir. I'm sorry, I'm bring material Indonesia language. Okay, Mr. Kita translate for me. Next. Ini profil saya. Jadi nama saya Suprapto. Jadi saya mulai menitik karir di dunia tambak tahun 97 di PT Sentra Pertiwi Lampung, lalu dipindah ke Surabaya, lalu menjadi technical support di Sentra Pertiwi India, langsung sampai sekarang saya diserahin di manajer technical support PT Deus Indonesia.
So this is Suprapto. He's already involved in many shrimp farming activities since 1997. His first experience in shrimp farming in Lampung, one of the biggest shrimp farming in Indonesia, in PT Sentral Pertiwi Bahari, and he already has more than 20 years experience in shrimp farming activities. And currently, he is a manager technical support stream in Deus, Indonesia.
Oke, next. Ya, ini gambaran dalam produksi udang. Jadi ini flow forecast farm operation. Jadi ketika kita mulai budidaya tambak, yang pertama kita lakukan adalah repair dan maintenance. Lalu repair dan maintenance ini meliputi ketika tambak plastik, kita ada yang sobek, kita ada program repair, lalu tanggul yang bocor, biasanya kita lakukan maintenance. Lalu di tahap kedua, kita ada pond and water preparation. Jadi di sini ada liming, pengapuran, lalu ada juga di sini proses fertilisasi.
So this is the overview of farm preparation and shrimp farming activity. The first one, we need to do repair and maintenance, which include providing plastic for the farm, and also we perform lining and also fertilization.
Tahap yang ketiga, kita ada dry stocking. Jadi di sini penebaran benur menjadi tahap yang ketiga, dan setelah benur ada, kita ada 4 tahap yang akan kita lalui untuk keberhasilan udang, yang mulai dari feed management. Jadi bagaimana cara kita memberikan pakan yang baik, berapa pakan yang kita berikan di bulan pertama, bulan kedua, bulan ketiga sampai panen. Lalu di water quality management, ini juga kita akan melihat bagaimana parameter yang ada di tambak itu sendiri, mulai dari nitritnya, mulai dari amoniaknya, lalu alkalinitinya, dan parameter yang lain.
So after doing pond preparation and maintenance, we need to stock our fries to the pond. And after that, we need to do some step for feeding management, which include how to give a good feed to the pond. And also we need to consider how many times we give per each month, something like that. And also for the second point here, water quality management, we need to pay attention to nitrogen parameters such as ammonia, nitrate, NO2 and O3, and also alkalinity.
Oke, di tahap yang ketiga kita ada pond pattern management. Jadi ini yang sangat penting. Kita budidaya di tambak, faktor pond management. Jadi nanti saya akan menekankan di faktor ini dengan SOP dari terus yang kita punyai. Lalu di shrimp head monitoring, ini biasa dilakukan para teknisi. Jadi ketika melakukan cek udang harian, jadi dia akan melihat dari udang sendiri bagaimana hepatonya, apakah berwarna coklat atau berwarna hitam. Nah, ini kita lakukan cek hariannya. Bu Vita.
Yes, and then the third point is pond bottom management. In this case, we really emphasize the activity, and he also have a special protocol from the host. And the next part is about shrimp health monitoring, where we need to check the quality of shrimp habitat pancreas, whether the color is brown, black, or other color. And also in this part, the technician will do daily check.
Oke, dan di akhir yang kita harapkan kita bisa harvesting dengan mendapatkan udang yang kita harapkan.
And the last step is we hope we will get what we want in the harvesting step.
Oke, next. Oke, ini gambaran cluster pump dari yang kita lakukan di tambak. Jadi mulai dari water source, dari air laut, biasanya kita masukkan di reservoir dulu, lalu treatment pond, lalu ada instalasi kanal distribution untuk ke tambak-tambak budidaya, dan yang terakhir kita ada pengolahan dari limbah.
Yeah, so our water source come from sea, and then from sea directly go to the reservoir treatment pond, and then from that we divide into the ponds culture, and at the last we also have wastewater treatment to treat the wastewater from the culture system.
Oke, next. Oke, ini konsep budidaya yang praktis. Jadi ini gambaran ada 3 kolam budidaya. Jadi ini penjabaran yang tadi dari air laut masuk ke reservoir. Ini kita endapkan, tujuannya untuk tom yang turun. Setelah itu kita lakukan treatment pond. Di sini kita ada melakukan pemberian kaporit dan lain-lain. Lalu kalau salinitas yang tinggi biasanya kita akan mix, lalu baru kita distribusi ke tambak-tambak budidaya. Dan ini kanal outletnya.
This is a simple farming concept. And then first, water from the sea will go to the reservoir. And then from reservoir, the water will be distributed into the pond stream. And in the reservoir, we do some treatment, I would say there, either chemical treatment and also for salinity, we need to adjust the salinity that is suitable for the shrimp farming activity.
Okay, next. Oke, next terus, next. Ya, jadi ini yang kita lakukan untuk tambak-tambak yang kita bina. Jadi strategi dari tambak kita ada 3 hal. Yang pertama masalah genetik. Jadi, genetik yang saat ini ada di Indonesia hanya ada 2, yang fast growth atau yang resisten. Ini mungkin nanti akan dibahas secara detail sama Pak Ari ya. Lalu yang kedua, tentunya pakan yang berkualitas, good quality. Dan yang ketiga, penerapan SOP yang betul. Bu Rita.
Yeah, our farming strategy consists of 3 points here. The first one about genetics, and in terms of genetic, we have 2 types here. The first one is the fast growth animals, and also the second one, the one has a good resistance in terms of disease. And in this part, Ari from the host will explain better about this part. And the second one, we also need to consider about feed. We also want to feed our animals with a good quality feed. And the last one, of course, about standard operational procedure, how we implement a good SOP to our farming activity.
Yes. Oke, dengan strategi yang bagus yang sudah kita lakukan, nantinya akan didapat pakan yang optimum, lalu pertumbuhan yang optimum, dan tentunya lingkungan juga akan bagus.
With this 3-point good farming strategy, we hope to get an optimum feed and also optimum growth to our animals and also good environment for our culture system.
Dengan ketiga hal ini, udang akan merasa nyaman, aman, sehingga akan berkesinambungan.
And with all those points, we hope our shrimp will grow safe, comfortable, happy, and sustainable.
Langkah-langkah yang kita lakukan diantaranya dengan melakukan biosecurity, jadi mapping area. Mapping area ini berfungsi untuk menentukan sejauh mana kepadatan yang ada di area situ. Bisa kepadatan mulai dari 30, 50, 60, bahkan sampai 300. Lalu kita juga harus melihat historial penyakitnya, lalu lokasinya, dan yang ini masalah konstruksi. Faktor konstruksi sangat berpengaruh di keberhasilan budidaya tambak ya. Lalu yang kedua, kita melakukan closed system. Jadi tidak terlalu banyak memasukkan air dari luar. Lalu biosecurity kita akan coba kuatin. Dan yang penting ini juga kita akan melihat cuaca. Jadi mapping session.
Yeah, to have a good farming strategy, we need to consider the biosecurity point of view. For this point of view, we have 4 factors. The first one is the mapping area. In this case, we need to pay attention to the history of disease in this area, for example, and also the location of the farms. The last one is about the construction of the ponds. And also about the biosecurity, we prefer to have a closed water systems. In this case, we use less water exchange, and then Of course, we will implement a strict biosecurity, and the last one is about season, because in Indonesia we have two types of seasons, and we need to pay attention when we need to culture and harvest.
Lalu untuk carrying capacity, jadi kita akan coba optimalkan untuk stocking density-nya. Jadi yang kedua, DO akan kita jaga di level lebih dari 4 ppm. Lalu untuk SOP, kita menggunakan konsep simbiotik. Jadi konsep simbiotik ini kita akan mencoba memanajemen airnya, lalu memanajemen dasar tambaknya untuk kesehatan udang sendiri dan pakan.
And the second part is the carrying capacity. The first one is we use the optimal stocking density. And the second one, we want to keep the dyes of oxygen level above 4 ppm. And the third one, we use symbiotic concept, where we combine probiotic and prebiotic in this case. And with aqua balance concept, we hope we can maintain water quality management, pond pattern management, and also shrimp health monitoring, feed management in a better way. And the last one, we want to have a partial harvest program.
Ya, oke. Dan yang keempat, kita mencoba melakukan partial harvest program. Biasanya kita lakukan dimulai umur 60 hari, lalu partial yang kedua di umur 70 hari, 80 hari, dan sampai panen. Kita bisa melakukan 3 atau sampai 5 partial harvest.
Yeah, and for the explanation about the partial harvest program, we can do it, for example, the first stage in the 60 days, and then we continue in the 70 days, 80 days, and then within one culture period, I would say, we can have several harvest times.
Ya, dengan SOP simbiotik, kita akan bisa mengontrol virus, lalu udang juga tidak banyak mengalami gojangan, sehingga udang nanti akan merasa nyaman dan aman.
Yeah, coming back to creating happy and sustainable shrimp in our pond, then depending on the SOP that the hosts have, we can control virus load in the pond, and also reduce the triggers factors that cause stress in the shrimp for shrimps.
Okay, next. Ini gambaran penyakit yang ada di Indonesia, disease. Jadi mulai tahun 1990 kita sudah disibukkan dengan penyakit WSSV. Ini belum selesai, muncul lagi TSV belum selesai, lalu ada MIO, YMFV, bergeser lagi WFD, dan yang saat ini yang sedang tren itu APEC.
Yeah, this is a brief overview of shrimp disease in Indonesia. So starting from 1990, we already experienced with white spot syndrome viruses, and it will continue with a different type of disease. And even until now, we're still struggling with acute hepatopancreatic necrotic disease, or known as early mortality syndrome.
Bisa jadi di tahun yang kesini nanti ada nambah-nambah lagi penyakit.
We can still expect more and more to come in the future.
Ya, kita jangan takut, tetapi kita harus bisa mensiasati ini semuanya.
We're not afraid of that, but we prepare for that to manage and organize our farm to be more resistant with disease in the future.
Next. Ini update penyakit di bulan Mei. Jadi di bulan Mei mulai dari Bangka, Banyuwangi, Bengkulu, Cirebon, di Lombok ada juga.
Yeah, this is the update of shrimp diseases in May 2023, so it's quite recent. it's a quite recent. You see a lot of cities in Indonesia experience disease and cost loss in because of shrimp diseases.
Ada APEN, EHP, IMNP, BFD, dan WSSW.
We see the most recent one here is the early mortality syndromes, AHPND, and also we still find some WSSV in some cities.
Next. Next. Okay, this next. Okay, I'm sorry. Simbiotik ini salah satu beberapa SOP dalam budidaya udang sampai sekarang itu banyak sekali SOP-nya. Dan untuk simbiotik sendiri kita berada di antara autotrof dan sama flow. Kita ada di tengah-tengah.
So for aquadynamic in the host, they have a special standard operational procedure, and it starts from the developing autotroph, conditioning autotroph in the water until the creating flow in water. In water.
Okay, next. Next is no. Next. Yes. Oke. Simbiotik sendiri sebenarnya perpaduan antara prebiotik dan probiotik. Jadi prebiotik ini kita bikin sebagai makanannya probiotik. Sehingga probiotik ini bisa berkembang sesuai yang kita harapkan ditambah.
So what is symbiotics? So symbiotics is a combination of prebiotic and probiotics. So we can say probiotics is a good bacteria, and this good bacteria, we feed them with prebiotics. So in a simple way, prebiotic is a food for probiotics so they can grow and multiply in our systems.
Yes. Bahan dasar untuk simbiotik sendiri itu rice bran. Ya. Jadi kenapa rice bran? Karena rice bran ini mengandung beberapa unsur yang sangat kompleks.
Yeah, one of the example of prebiotic in Indonesia is the fermented rice bran. Why? Because this ingredient contains complex carbon, which can be degraded by probiotic and multiply the growth of probiotic in systems.
Untuk simbiotik sendiri kita ada dua. Untuk air ini yang kita lakukan. Lalu untuk pakan sendiri, untuk menaikkan imun udang, kita mencoba membuat aminopeptida sendiri.
And to improve the growth of shrimp, we include aminopeptide in our symbiotic.
Very close to time, sorry. Don't know how long you still have.
Waktunya sudah habis.
Sudah habis? 5 minutes, sir?
5 minutes?
I mean,
They have a later lunch anyway, I guess, so.
no problem.
Go on.
Next. Next. Ya, ini secara ringkas simbiotik yang kita lakukan. Ini instalasi yang kita lakukan ada di tambak, sangat mudah sekali. Next. Ini pembuatan aminopeptidanya yang kita lakukan sangat hemat dan sangat bagus untuk pertumbuhan udang. Next. Next. Ini next. Next. Oke, next, no problem. Ini tambak-tambak yang kita dampingi. Jadi ada sekitar 454 kolam yang kita dampingi mulai dari Aceh sampai Lombok. Ini oke, next. Dengan simbiotik ini sebelum memakai simbiotik dan ini setelah pakai simbiotik. dan kita ada increase di produktivitas 41%.
Yeah, so this is a little bit the overview of before and after symbiotic application, and we see here an increase of around 40% of increase in growth after symbiotic application.
Next, sir. Next. Okay, next. Okay, next. Ini aktivitas kita dari tim technical the host kita untuk mensupport dari petambak-petambak di lapangan.
This is the overall of team activity in the field. They support the farmers to apply symbiotic.
Next. Okay, this is my product the host. Next. This is my factory. Next. Oke, jadi tim yang kita di Daus kita lakukan, kita mencoba bekerja dengan hati. Karena dengan bekerja dengan hati, semuanya akan beres.
This is a good one actually. So his motto is to try to work with heart. Once you work with heart, and then everything will be solved at the end.
Okay, thank you.
You also thank you to Rita, of course, for the translation. So that made it a little bit longer. So next up, I want to invite Mr. Ari Setiardi. I hope I pronounced it nice. Ari is with Hendrix Genetics. His job is providing Vaname shrimp broodstock originated from Kona Bay, Kauai, Hawaii, to all Indonesia customers. And he's going to talk about building sustainable aquaculture with genetically improved shrimp.
Okay, good morning, everyone. My name is Ari Setiardi. My name is Ari Setiardi. I'm from Hendrix Genetics, but I'm not a Dutch. I'm purely Indonesian. Yeah. It should be that Robert Long, my director of R&D, presenting, but last week he already had a seminar in Indonesia, and last week also already left Indonesia. So this is my presentation of building sustainable aquaculture with genetically improved shrimp. That they already also have a quite good presentation about the farm management, and I will share about how we create this genetically improved shrimp. Next. Yes, this is the mission of Hendrix Genetics, supporting the global food challenge with high quality animal genetics. We know that the people growing, especially in Asia and Africa as well. So we need a lot of support to feed them, but with the this way that this genetically we have to be responsible, and also reducing the footprint as well, and also animal welfare as well. So this is our concerns of Hendrix Genetics. Next. This is the operation of Hendrix Genetics. We breed multi-species in global reach. We have 7 species: layer, traditional poultry, turkey, swine, and the agriculture is trout, salmon, and shrimp. Yeah. Next. Yeah, with total employee about 3,500 in the operation of more than 10. Let's see. Next. Yeah, this one in US we have a trout nucleus, and in also shrimp nucleus. In Ecuador, nucleus and multiplication. In Chile, we have a salmon nucleus. And India shrimp multiplication, but just built, yeah, will be upgraded the next year. Indonesia, we have a shrimp multiplication. So nucleus is in Hawaii. In Malaysia, we also have nucleus and multiplication. Next. Yeah, so, but genetics is only the part of the solution that mentioned by Pak Suprato, that they use in Indonesia, we use actually 3 genetic, yeah, fast growing, survival, and also balance. So the performance of the animals in the culture is depend on the genetic and also the environment. If we really take care of the environment, so all the potential of the genetic will be expressed. So this is what genetic breeding cycle philosophy. In shrimp, we have nucleus in Hawaii. So this nucleus keep in biosecure environment. So then we send the brother and sister of animals in the nucleus to the sentinel pond, and also in area that we can challenge the animal with some maybe disease and environmental challenges as well. So this nucleus not sent to the sentinel or the challenge pond, but still stay here in the nucleus. And then the information of the performance in the sentinel pond then have a feedback to this nucleus. So with this cycle, we can have new families and then evaluate the candidate, and then the best performer will be the elite broodstock and will send to the production. So right now we send to Indonesia as well for PTL or for the broodstock candidate. So this is the breeding cycle, and we have every 6 months we have a new generation of better performance of the genetics. Next. So this is just a description of that. We have the population, and then we select for the best performer, and then the population also can have more better in every generation, have new improvement. This can be in growth or in survival, and many parameters that we want to select. So breeding can be used to gradually improve the population. So this one about the description, and this is what we already see before, that we need this data collection analytics as well, and then genetic evaluation, animal selection, and then we can have the new generation. This is the genetic process of our breeding program. Next. So this is we have this data center as well. So this is the trained population that we send to the sentinels, and we get all the information about survival, about the disease challenge and everything, growth. So then we have more than 1,000 DNA markers, and this one we keep on this database center, and then we select the family in the nucleus based on this data. So then this also take the DNA genotyping, and then we also match which is have a best performance in this sharing population. So actually in this this is the in the so the decision is much more accurate than family selection because we use the DNA markers. Sorry, it is in the nucleus. Yeah. Next. And there that we have also challenges using EMS challenge with extreme pressure of pathogen in laboratory, and then until natural fade out of mortality and no treatments, which animals will survive. And we see that in next batch we have a better survival against EMS challenges. So right now we are also have challenges of few pathogens that exist in Indonesia as well. Next. So with this genetic selection, you can improve the heritable traits. Yeah, only heritable traits. This increase growth, the survival as well, and also indirect reduction of food conversion ratio because they have a faster growth. Also improve plant-based diet utilization, and we try also to treat for the tolerance of reduced water quality because we have various environment of culture in Indonesia as well. We have area that very difficult, like in Java, or area that still quite good for this farming. So we also use this one to feeding of the tolerance to reduce the water quality as well. And also because the broodstock will produce PL in hatchery, so we also improve the reproductive rates. So like the nuclear plus spawner, mating rate, and mostly of the productivity in hatchery as well. Okay, next. Yeah, this is the balanced breeding because in shrimp we cannot really control all the environment, so we need to make or create the breeding that is balanced between the growth and the performance or disease resistance. So mostly the animals with the fastest growth will have less resistance, and the most resistant will have less growth. So we select on this balance, but we have still have a good growth and also a good disease resistance. Next. Yeah, this is our balance breeding. So maybe in other animals, mostly is with we use fast growth animals, but in shrimp we use balanced breeding because, as I mentioned, that we cannot really control all the environment. So we select the performance is one, with the performance sometimes with ablation, sometimes without ablation. Ablation is taking out the egg stalk to faster the mating of the female, And then we also give a specific disease challenges with high density, the temperature fluctuation, low O2, and survival at pond, and early and late growth. Because sometimes in pond, the animal shows a little bit late growth in the first 30 days, and then show a higher growth in the next. But we try to have both the early and late growth, and also survival in hatchery and also in pond. So this is a balanced breeding. We select for a lot of parameters. So we have broodstock or PLs that have this kind of advantages for the farm. Next. Yeah, so this is we can also pick from multiple environment. Yeah, that I inform you that this environment may be not so good because this is traditional pond without or very less of this one, no aeration, and this is one is the pond that maintain in more intensive, yet it is traditional intensive. So this one maybe can perform better in this environment, which this one perform better in more better environment. Next. Yeah, so this is our product that we can also raise in extensive environment, extensive farm, and this is the moderate, maybe semi-intensive. This is very intensive farm. So because in extensive, usually the environment is not so good, so we use this high resistance line with the slower growth. And for the intensive farm, we use fast growth but with low resistance. But mostly we use this product with moderate growth and moderate resistance because in Indonesia also most of farm still in this phase. Next. Yeah, this is again that I mentioned that improvement in the genetic also need a change in management. So change in SOP of the farm, also a better feed. Yeah, because after we improve, then we need to adjust the farm management here. Because improving in genetic but without following with adjusting in farm management will not, the animal will not express the maximum potential. Next. Yeah. Yeah, there's a cycle on. Next. Okay, thank you very much.
Thank you, Ari. So our next speaker is online. This is Dr. Andi Paranrengi. Dr. Andy is a research center for fishery, natural research, and innovation agency, BRIN, and he focuses on genetics, breeding, and biotechnology.
Yes, I'm the Zoom now. Will you please to give the access for the screen, share screen? Can you hear my voice? Hello?
Yes, it's clear.
Yes,
Andy.
okay. Thank you very much for moderator. I would like to introduce myself. My name is Andi Parendreng from the Research Center for Fisheries, BRIN. Today, I would like to present the current status of research effort of the shrimp aquaculture in Indonesia. I apologize that these too many slides have to present it today. So maybe some of them I would like to skip because of the time. Outlines of our presentation is we have to introduce the brief of Indonesia shrimp production and some research on supporting the aquaculture production like the land suitability, breeding and domestication, nursery and grow out, shrimp health management, integrated shrimp farming, and maybe the last presentation we will share about the research need for the shrimp culture. In the first, I would like to introduce the brief insight of the Indonesian shrimp production. If you see this slide, the status of the shrimp aquaculture in 2022, according to the Ministry of the Marine Affairs and Fisheries in 2022, for the system aquaculture consisted of the three systems are intensive, semi-intensive, and traditional. For the total area of the shrimp aquaculture, around more than 300,000 hectares, and the production to 2021, almost in 1 million tons. If you see this picture about the shrimp production and the shrimp production in Indonesia, I think the species of the phonemy is dominated for the production and production industry in Indonesia. If you look at the bottom of the graphs, we can see that for the production during the 2019-2021, the top 5 shrimp production according to the province, I think the first is NTB, the area of this symposium conducted. And the second is Jawa Barat, and the third is Jawa Timur, Lampung, and Aceh. I would like to highlight some research supporting to the shrimp aquaculture in Indonesia. Of course, the first is the land suitability, because land suitability is the first consideration before to develop the aquaculture in Indonesia. This study make the recommendation to the government which area is suitable for the brackish water and also for the marine culture of Indonesia. We have done some surveys around 43 area in Indonesia for the brackish water pond indicated by the red dot, and also for the marine culture indicated by the blue dot. This is the one sample of the recommendation for the study on the land suitability we conducted in Baru Regency. This is a map identified that the area is suitable for super intensive technology of the white shrimp. And the second output of the land suitability for tiger shrimp farming, and also have to make recommendation which area is suitable for the tiger shrimp farming. Especially this is, for example, in the Luwu Regency, South Sulawesi province. And the other survey regarding to the water suitability for the seaweed culture using the long line method, we have to make a study on some bays in Indonesia, namely Talengan, Manado, Davao, Sangihe Island. This area has been identified which area is the suitable for the seaweed culture using the long line method. Highlight of the breeding and domestication program on the shrimp. In Indonesia, we have two species for the breeding domestication in focusing of the domestication program. The first is the tiger shrimp, and the second is banana shrimp. This is just to show how to we do characterization of the founder before we are going to the make the breeding and domestication program for the future. For example, we have to identify which the source of the broodstock. In Indonesia, I think the mostly of the broodstock come from the Aceh. And the other characterization about the reproductive broodstock, and also characterization to phenotype and genotype characters. After we get the offspring, we have to evaluate the post-larvae and also morphological and vitality tests. This is the history how to the tiger shrimp domestication conducted in Indonesia around 2008-2016. For domestication, we have to successfully to make domestication of the tiger shrimp, both for in the pond and also reproduction in the tanks. This is the highlight domestication in the pond, like semi-intensive, older system, the growth, longer period, and so on. And also for the reproductive in the tanks, we also to highlight the finding, the healthy and side broodstock selection, measurement and density, sex ratio, and so on. To produce the broodstock from the breeding domestication of the tiger shrimp, we start from the wild broodstock until that we get the mature broodstock. For the breeding program, we use the individual selection. The status now is that we can get the generation 6 for the tiger shrimp. This is the show the how to evaluate the growth performance in the tiger shrimp compared with generation 1, 4, and 5. In the growth of the 6 month, 11 month, and this is the features also show the specifically to get the data, the performance of the 5th generations. I think this is the 5th generation. We can get the survival rate around 23 to 75% based on the period of the rearing process in the pond. And also we check the fee of the disease, WSSV, HNV, TSV, MBV, and IMNV. The second focus on the species of the shrimp for domestication is the banana shrimp, Medioensis domestication. This is also we have to perform the successfully to seed production technology, including the broodstock density, female-male ratio, food and feeding, and environmental parameters, and also how to produce the seed. Also have the protocol to produce the seed technology for the production of the seed banana shrimp. The left side is just to show the growth of the banana shrimp. And banana shrimp, we have the successful domestication in the pond and the tanks. This is the highlight of the some result of the research is in the pond and the tanks, limited in the pond. The sexing very important to understand and grow faster in ethanol pond at low density compared to the tank. And healthy broodstock successfully produced now until we get the 4th generation. And also we have to find some technology to stimulate the maturation by using the biofloc. In the bottom graphs also just to compare the performance between the G1, G2, G3, and G4 that I have done for the study. Also, we have some research in supporting the shrimp breeding program, breeding and domestication program. The first is diet development. in this study, we have to focus on the two stages of the broodstock, maturation stage, 30 to 80 grams, and maturation stage, more than 80 grams. For the maturation state, we have to focus on to find the carotenoid supplementation, vitamin C, and vitamin E. For the maturation stage, we have to find the feeding regime using the breastfeed and pellet diet. And also, we have to get the 10% can be used for the polyethylene in the feed of the maturation stage. The next research supporting the shrimp breeding and domestication, we also have the hormonal manipulation. In the captive tiger shrimp, the most problem is male. So we have to improve the maturation of the male by injecting of the OC developer. We conducted this study for the wild male. But for the culture male, we have to study about the injecting of the salmon gonadotropin release hormone. This is feature also show how the dose to stimulate the spermatophore about the 84%. And the other research supporting the shrimp breeding program is the application of the probiotic. Here we are showing the application of the RICA probiotic, RICA in terms of our institution before, Riset Institute for Coastal Aquaculture. We are focusing on the both form of the probiotic, liquid RICA probiotic, and also the powder of the RICA probiotic. You can hear here how the optimum doses, how the frequency to use for the produce the larvae of the tiger shrimp. And the other supporting shrimp breeding and domestication program, we use the MT hormone to improve the productive tiger shrimp. And also the same the tiger shrimp, we found the best dose to improve the reproductive tiger shrimp, and also the frequency and how to the administration method to apply to the tiger shrimp broodstock. And the other is study regarding to the RNA technology, the sRNA on the tiger shrimp. This is study also conducted to support the breeding program, including the study about the basic research to isolate, to cloning, to production, and so on. And also we have to establish method of the dsRNA application, like to using the larvae, using the juvenile, how to enrich to the feed. And the other component we have to study to assembling the technology of the RNA, like application to the what the stage we have to start to application, the optimal injection, and so on. And the last, I think we have to develop the dsRNA application in the nursery and grow out pond in the system on the culture of the tiger shrimp. This is the bottom just to illustrate how to the this research conducted by nursery, by challenge test, and grow out, and some graph also showing the performance after we conducted the research. We are moved to the research on nursery and the grow out of the shrimp. I think the first is nursery system is already recommended to the government to performance before to grow out in the pond. You can see here the advantage of the nursery phase. In Indonesia, nursery system we can found in the some types. Sometimes the fishermen using the fiberglass concrete tank, also using the hava, and also using the small pond inside of the largest ponds. This is the table showing the characteristic of the nursery pond in Indonesia, stocking density, rearing period, and survival rate. In the nursery studies, also we have done the using different level of protein of the feed. It means that how much protein is better for the nursery of the Peneus monodon, and also system aeration. Also, we have to evaluate for the nursery pond, nursery system, and Peneus monodon. And the other nursery research about the household scale white shrimp. In bahasa we call budidaya paname rumah tangga, sistem rumah tangga. This is show how the performance when we conducted the household scale white shrimp in nursery with a circulating aquaculture system. We are going to the nursery economy. We have to some researchers about the different density using aeration system of the pond. So we have to make the different density and evaluate how the survival number, how the specific growth of this research. And we are going to the grow out. This is the, I think the grow out is the we conducted after we using the nursery. This is a research also showing that the grow out using a different time nursery. It is mean that the use of the seed from the nursery is better than the which is not from the nursery. I think this is the nursery phase strategy for obtain uniform in the size, higher survival rate, and more tolerance of the environmental variations. And also we have to cultivation on tiger shrimp with different stocking density in semi-closed risk system using the mangrove survive. This is also to understand how the different stocking density using the semi-closed circulation system. And the next is also the supporting reset, growth performance, and broodstock to different generation. We also to evaluate the different generation to produce the broodstock from the breeding. And the specific for the phoneme, we have to some research supporting for the shrimp culture. We call the progressive system. The progressive system is include the culture of the super intensive phoneme. So you can see here, if using this progressive system, the system as survival production size is almost bigger than without using the progressive system. And the last grow out, I think the how to minimize the waste of the super intensive phoneme shrimp aquaculture. We study the two different prototype slide. The first is the central drain, and the second in slab collector. Here the table showing the performance of the super intensive phoneme shrimp aquaculture by using the central drain and slug director. The next highlight of the research on the shrimp health management, we have to the monitoring of the shrimp disease in brackish water, just to monitor the status of the shrimp disease in brackish water in Indonesia. After that, we can get the recommendation. We can give the recommendation to the government. Based on our monitoring, we can say that for the tiger shrimp and the phoneme, the most disease of the Indonesia is the white spot syndrome virus and fibrosis. We have also the evaluate the kit, the detection for the shrimp tuberculosis. We have to produce the specific kit for detection, and shrimp tuberculosis is very effective and efficient to detect the shrimp infected by Vibrio harpae. And also the shrimp health management focus on the application of the RICA probiotic to shrimp disease prevention of the shrimp aquaculture. Here, this is highlight some research about the probiotic we use for this research, and also we have to get the patent, 2 national patents. And the screening test for shrimp post larva is also recommended to the government before use to the grow out or nursery program system. So we have to prevent from the false negative detection. I think it is the recommendation to get healthy the post larva before to culture. And the other shrimp health management studies to support the shrimp aquaculture is using the microalgae for the species control. We have to for this is the using the whole microalgae, and also the using the extracted of the microalgae using the supernatan. And the other highlights of the important finding of this health management liquid fertilizer, use symbiotic feeds, mangrove herbs, and also use the microalgae for the disease control. And the second point for the...
You don't know how many slides you still have left?
How much?
Yeah, we're a little bit out of time, so I don't know how much slides you still have left.
Okay. A phenomenon study, we have to using the study to know which the area is area. Like for example, this is HP positive at district of Negara and in Lateng, and the other is still moderate of this. And epidemiology study, this is the risk factor. And the last research, I think the integrated shrimp farming. For the integrated shrimp farming, we have to focus into the 2 focus in polyculture system, and the second in the INTA system. We have to some study about the INTA system in the pond, INTA color, and also in the some area in a farm of Mamuju, West Sulawesi. It is the last I think for our presentation. I think this is very important to this symposium for the research need for the aquaculture, because maybe this aspect is possibility to get the collaboration about for the national and international institution, I think. The aspect of future research for the shrimp aquaculture, the first is environmental carrying capacity and appropriate zoning for aquaculture activity. And the second aspect is diversification of important aquaculture commodity, including the domestication, selective breeding, genetic improvement, INTA, and so on. Climate change, resilience, water pollution, zero-waste aquaculture production system. And the third is shrimp health management based on the use of natural materials. And I think the last is sustainable aquaculture practices and implementation of aquaculture development policy. I think it is enough our presentation, and I will back to the moderator. Thank you very much.
Thank you. So we're at the end of the talks. So I actually want to ask all the speakers to come in front for a small discussion session. It is already 12, but we already started a little bit later as well. So it's not so much that the talks were longer. So we'll do the discussion. Depending a little bit on the amount of questions. So I would like to ask speakers to come in front. Okay. So is there anybody who has a question? Yes?
I have one question. So, moderator, can I ask my question to the speakers?
Yeah, go ahead. We'll do the other one afterwards.
Okay, so my question is to Professor Gerd. We know that shrimp only rely on the non-specific immune system, Professor Gerd, and one approach is by the upgrading by the using the beta glucan.
That you ask in the chat. So I can read it for you. So this is the question for the shrimp to increase their immunity. Question: should we vaccinate periodically, which is one quality using certain bacteria probiotic? Yeah, I think this is the question of this Mr. Haryadi.
So if I get the question right, is did I ever test how long the trained immunity lasts?
Yes.
Yes. No, I didn't test. Not in shrimp, not myself. We've done experiments in fish. And I think nobody actually really knows how long it lasts. So the only thing I would say with my presentation is people should try. So far, people always assume it would last very short. So nobody tested it. So he should definitely try to see if the effect lasts long. Expect.
And should we vaccine periodically?
I heard a motor bicycle passing by. Can you repeat the question?
Should we vaccine periodically?
Yeah, so should we treat periodically? Should we treat periodically, right?
Yes.
I don't know. I think in theory, if you think in trained immunity, can be in theory several months, and the production period is relatively short. So we saw one of the presentations that you can raise your young phases in the RAS systems. So I would say if you have a very healthy RAS system, you could train them early. You could probably get quite far into your production system. So then there wouldn't be, but this is my theory. I think you should try and practice.
Which one is better, to train the shrimp with vaccination, or we maintain good water quality using bacteria probiotic?
So you ask which is better?
Yeah. With vaccination or maintain a good water?
You should do both. So, I mean, definitely you need a good water. So when I listed all the points from ChatGPT, all those things you have to do, that's your starting point. And then if you want to stimulate the health or the immune system, you add that on top of all the other things. So it should be both.
Maybe we can do the next one, which was on Zoom as well.
Yeah. The question is in Indonesia for Pak Suprapto. Bagaimana isu implementasi climate smart aquaculture pada budidaya udang sistem intensif?
Okay.
To translate. Yeah. To implement climate smart aquaculture for shrimp aquaculture.
Masalah klimat ya, cuaca Ibu ya.
Climate smart aquaculture.
Baik, terima kasih. Jadi masalah budidaya udang, memang salah satu pengaruhnya itu dalam hal klimat ya, cuaca. Jadi kita pernah mengadakan beberapa pengumpulan data panen. Jadi di bulan-bulan tertentu memang secara performa itu ada penurunan budidaya.
Yeah, so the question is about how is the effect of climate to the shrimp farming and shrimp productions. And based on his experience, different climates is affecting the production of shrimps. And yeah, certain climates might reduce the production of shrimps.
Ya, jadi dalam satu tahun kita coba bagi beberapa periode bulan. Jadi mulai Januari, Maret, lalu April, Mei, Juni, lalu Agustus, September, Oktober. Ternyata yang paling bagus budidayanya di data kami itu bulan Oktober sampai Desember.
Okay, based on his data, he tried to culture shrimp in 1 year, and then the best performance mostly happened from October till December.
Ya, ini data dengan total tambah ada 225 kolam.
With a total data from 225 ponds.
Ya. Oktober sampai Desember. Ya, ya. Jadi menunjukkan malah lebih bagus di situ. Bulan Oktober sampai Desember itu hujannya tidak terlalu tinggi. Justru di Indonesia saat ini itu paling tinggi itu bulan Januari. Januari, Februari ya.
So October is basically rainy seasons, but something shifting now in Indonesia. From December, the intensity of raining is not that hard, not heavy, but now it's a bit shifting in January. So that's why we have a good production from October.
Yeah.
I have a question. Maybe you can mute your microphone. Would you like to give a question? Let the person in the room let the question first now.
Hello, good morning. My question to Mr. Suprapto. I'm sorry, I use Indonesian language. Jadi pertanyaan saya, jadi sekarang kita mengetahui perkembangan tambak khususnya di Lombok itu lagi berkembang pesatnya. Namun kita tidak bisa pungkiri dampak dari pembuangan hasil limbah tambak yang berakibat kepada biodiversitas maupun bagaimana kondisi yang ada di sekitar dari tambak tersebut. Nah, mungkin dari segi hasil limbah atau pembuangannya tersebut, mungkin bagaimana cara penanggulangan serta mungkin dari pakan yang digunakan serta bagaimana inovasi yang mungkin bisa dilakukan untuk dapat mengakibatkan lingkungan tersebut menjadi tidak normal seperti itu. Mungkin itu saja pertanyaan saya. Terima kasih.
So yeah, the question is about, correct me if I'm wrong. So he asked about now, we know now that the shrimp farming activity grew massively in Indonesia, and we also need to consider the effect of wastewater from shrimp farming. And this wastewater can impact the biodiversity around the farms, right? So how do you see this issue?
Oke, Mas siapa namanya? Sorry.
Saya Farudal Aldi. Aldi.
IT.
Ya, Aldi.
Aldi, oke, baik. Mas Aldi ya. Jadi ini masalah sangat krusial ya. Masalah limbah tentunya ya. Jadi di SOP kami di The Host itu ada namanya simbiotik. Jadi dengan SOP ini memang kita fokus di masalah limbahnya ya. Jadi sebagaimana kita ketahui dalam kita pemberian itu pasti limbahnya lebih dari 15%. Ya, itu menjadi fokus kami. Tapi dengan penerapan simbiotik yang bagus, limbah yang dikeluarkan dari tambak ini akan lebih bagus. Dalam artian gini, kita bisa melihat dari baunya, ya itu paling mudah. Jadi ketika kita membuka sub outlet di tambak ya, itu baunya kalau bakteri ini bisa bekerja dengan baik, itu akan harum. Tidak seperti biasanya sangat, ya maaf kata ya, itu sangat busuk ya. Tapi yang kita lakukan saat ini sangat harum gitu. Makanya kadang-kadang tambak-tambak kita yang dekat dengan tambak-tambak dengan pertanian itu malah diharapkan. Karena air dari buangan ini itu malah dibutuhkan.
Yeah.
Kepanjangan.
So it's quite long. So yeah, correct me if I'm wrong again. So the first thing is, according to the WHO's protocol, they apply symbiotic in their feed, and this symbiotic help to degrade organic matters from excess feed, and it also improve the quality of wastewater. And also some farmings, they integrate with rice field, I would say, that kind of agriculture activity. So the wastewater can be also used for further activity in agriculture. Yeah, activity.
Okay, so we have on Zoom, we have still a question with someone, I think it's Romy Novaridi.
Yeah, thank you. My name is Romy Novradi. I'm coming from the Jakarta Technical University of Fisheries, Ministry of Marine Affairs and Fisheries, Republic of Indonesia. I have 3 questions. First to Professor Gerd, and then the second one is to the Mark Vergem, and the third one is Eliza. To Professor Gerd, we know that the shrimp only rely on the non-specific immune system, but you know that there is one area in shrimp that not protected by exoskeleton, what we call as the antennal gland, and this is the urination process. So you know, during the heavy rain season, there is a massive intake of the pathogen come to the shrimp using this antennal gland. So you said that we know that the priming system can also enhance the stimulation of the non-specific immune system, especially for the humoral and molecular level, like such as a prophenol oxidase that you say. But how to maintain this non-specific immune system only on the top level? Because my research, the immune system, the non-specific immune system, we can stimulate them, but only in the short period of time. You know, but there is a continuous intake of pathogen using the antennal gland, and then it goes to the hepatopancreas of the shrimp, and this non-specific immune system only can stay on the short period of time. So what is your suggestion to maintain this non-specific immune system, phagocytosis, prophenol oxidase, only always in the top level to protect the shrimp against the pathogen infection? And the second one to Mark, I saw your presentation, Mark, about the differentiation in growth performance between the 27 post-larvae per cubic meter compared to 300. Yeah.
Can you hear me? Sorry.
I can hear you. I can hear you. Can I continue the question?
At a time. Sorry. So maybe Geert can answer the question first.
Okay. Okay. Thank you.
Yes, this works. Thank you very much for your question. You obviously know much than I do. So that's very nice to hear. I think you're right. Shrimp is exposed to a lot of pathogens very regularly when it's let's say goes through the metamorphosis. It will not lose its cells. So where I said cells with your receptors, those cells will remain. Innate immunity is supposed to be very short. And the only point I want to make with trained immunity, which is based on innate immunity, is it may last longer than we think. Because books tell us it's very short. I would say the new textbook tells us it can be longer. And how long exactly is what we need to find out together. I believe you have a lot of experience with shrimp. So please do the experiments and come back to me and tell me it works for 3 weeks, it works for 3 months. So please try and come back to me.
Yes, Professor Gerd. I mean, 3 months the shrimp is already harvested. So it's not, but my research right now is only using the fragmented DNA. When I cut the DNA of the conspecific microorganisms and then put in and then immerse them with the shrimp, it can also protect by by degrading the nucleotide of the pathogen, and then they cannot grow in the shrimp. So that's I would like to discuss more with you about the functionality and the functional role of this fragmented DNA, because this is very interesting. I think it's work in plant, but never there is no one that doing research in aquatic organisms. So fragmented DNA, when we can cut the fragment and then put into the hepatoplankton or the shrimp, they can also release a substance that can destroy the nucleotide of the pathogen, and then the pathogen cannot grow. So probably there's another future research that we can collaborate. And if I may have another question with Mark, with the biofloc system, Mark, I see that the density of 27 have a bigger growth performance compared to 300 post-larva square meter. Is it because of the biofloc or the carrying capacity, Mark? Because and also in the diet formulation, why you only supplement the lysine, methionine, and threonine in very low level for 12% fish meal compared to 21% fish meal? Because we need to formulate the diet to fulfill the specific nutrient requirement for the shrimp. But I saw that with the low level of fish meal, but you only supplement with the low level of lysine, methionine, and threonine, because these 3 limiting amino acids are very important for shrimp. That's why the growth is not, it's not similar. If you design the diet become isonitrogenous diet, we need to see the nutritional profile of the diet first, and then we can get the conclusion whether this biofloc system can work, or this is just about the carrying capacity, because the diet is not similar, it's not isonitrogenous. My last question for Eliza, because you said that there is a several starch level for the ingredients.
I'm sorry, can we just do one question for Mark first again?
Okay, thank you.
The first question is that the difference in growth between stocking density of 27 and 300 animals per square meter. I did not understand exactly what difference you were hinting at. So it
yeah, there's a differentiation in growth performance, Mark. Yes, if I'm not mistaken, I see your presentation.
Yes.
You see that there is a 27. The individual body weight of shrimp at the final harvest is higher compared to the 300. Is this because the carrying capacity with 27 is bigger than the 300, or because of the biofloc system?
Well, the carrying capacity was not bypassed or surpassed, but because the density of the animals in the system was very low, and the total production per unit of volume of water in the system was very low. So the carrying capacity was not the issue, and but over the years, we have done many experiments, and we always see that when you go to a lower stocking density, the individual growth is higher, and your total production is also lower than when you go to a higher stocking density. But at a higher stocking density, your growth is lower. Now, I think that because there are many questions about what is a healthy aquaculture system. And actually, we put our animals in densities that are higher than what normally we work with in nature. And that apparently the animals react to each other. When the density is high, they grow less, and even if you feed them. And that's something that I think we could do more research on. What can be the reason that is happening? I don't know the exact answer to your question, because I did not do research into what is now the reason that the growth is less, but it's very common with fish, with shrimp, that we see the same thing. And your second question, can you repeat your second question, please? Or
yeah, for the diet formulation, Mark, for the diet formulation, I saw that you supplement the diet with lysine, methionine, and also threonine. But I see that in the diet formulation, when you said that you design the diet become isonitrogenous diet, but I only see the supplementation level of lysine, methionine, and threonine is very low with the wheat bran diet. In fact, the wheat bran diet is only 12% fish meal inclusion level, only 12% of fish meal there. Compared to the 21% fish meal, we expect the lysine, methionine, and threonine will be higher compared to 12%, but you still supplement the diet with even higher lysine, methionine, and threonine. So I'm not seeing there is a nutritional profile of the diet with your research, Mark, but I expect that the lysine, methionine, and threonine should be higher in 21% because you supplement them with 0.3% of lysine, for instance, but 12% the fish meal with low level of lysine, you only supplement even lower. So I expect the growth performance will be disrupted because of the nutritional profile of the diet is not fulfill the requirement of the shrimp with the wheat bran. So how you can explain, Mark, why you supplement the lysine, methionine, and threonine in the higher inclusion level of fish meal even more compared to the wheat bran diet that only receive 12% inclusion level of fish meal? Thank you, Mark. Moderator, I'm not hear anything.
What? Oh, so with I now answer shorter. We did the experiment actually in a pond environment with biofloc in it, and by experience we know that the pond provides a lot of nutrients, and so we added a little bit of these amino acids in the diet, but just as a precaution. But we know that through the environment, the animals get access to these nutrients. So yeah, in an aquarium study, you are right, but in a pond study, the pond provides a part of the nutrition. Yeah.
Thank you, Mark. I agree with you, but this is, I think, the two diet is using in the similar environment, right? In the biofloc system, the the corn diet and also the wheat bran diet. I think so, because there is in one table. But I think that why the growth performance of shrimp is not have any significant difference, because probably the 21% fish meal, because we not see the nutritional profile of the diet, so we cannot get any conclusion here. But my suggestion is, if we can design all the diet have a similar nutritional profile to the shrimp, probably the result will be different, because they culture in the green water technique in the bioflux system together, but the final weight gain 6 gram compared to 5.8 gram with a p-value of 0.107 can be different if we design the diet become more, fulfill the specific nutrient requirement of the shrimp. I'm not sure what is the lysine, methionine, and threonine level at the formulated diet at the final product, but I think this also affect the growth performance of the shrimp.
Maybe it was not clear. Okay, the two diets were different, but the diet, the control diet, we gave the control diet and we supplemented with the system. So in the systems, the total input of nutrient was the same, exactly the same. And it, so maybe you don't consider the wheat bran inclusion in the system, and it, but so the message or the outcome of that research is that the way you add the wheat bran, you give it in the diet or you give it besides the diet, doesn't affect the outcome of the experiment. That is the main conclusion.
I see. Thank you, Mark. I think my final. Thank you, Mark.
My pleasure.
Can I have another one question, moderator, to Eliza about the alternative ingredients?
Yeah, we can hear you. So if you just formulate your question, please.
Thank you for the very great presentation, Eliza, about the alternative protein source to the fish meal. We know that, yes, plant protein source have a problem with the starch levels. What do you think about the use of the protease in the diet formulation? If you think this can work, I think can you mention about what is your strategy to maintain the integrity of the enzyme or phytase after they pass through the extrusion process? Thank you, Eliza.
Thank you for the question. If I get it right, you're interested in the phytates in the diets, right?
Yes, and also another possibility to using enzyme to reduce the starch levels in the for the ingredients, especially when we want to produce the floating or semi-floating diet with the extrusion process. Can we do that things, and what is your strategy to maintain the integrity of phytase or enzymes at the final product? Thank you.
So I'm not really an expert on like extrusion or like feed processing. So I will just answer based on the knowledge that I have so far, because in normal studies, the diets were extruded. So of course we expect some effect on the availability of nutrients in the diet. And extrusion is normally a process that, at least when we are talking about carbohydrates, it gelatinizes the starch. That makes the digestibility of starch at least higher. So in most cases, it is something comparable, but still a bit negotiable is if there are also some negative effects that come out of this process. When it comes to phytate, I think that you can actually increase phosphorus availability through the processing. So I would expect actually to also have like a positive effect during the extrusion process. I hope that answers your question, Anastasia.
Yes, thank you. Thank you for all speakers for the great presentation. I learned a lot today. Welcoming you to Indonesia. I have one farm in Lombok, actually in Pringgabaya, in East Lombok. I'm supervising the shrimp production there. We just harvest the shrimp, and we would like to start the new cycle next month. If you're still here, I would like to invite you to my farm in Lombok, in Pringgabaya, in East Lombok. So there's a good opportunity to meet you guys. Very well-known expert in the shrimp culture. Thank you.
Thank you. So we have maybe time for one small question from the room. One very small question, then we go for lunch. Yes, in the back. I don't know if you want the microphone.
Thank you. The question is very interesting. I is really recognition or how allow the allowance of the 8.60% and the population and okay, I get the question. So maybe I repeat the question. So I lower the input of the feed by 50%.
Lower the feed to 60%.
But so when I lower the feed input, the carbon input is also lower.
Yes.
And the carbon I replace by adding carbohydrate. Yeah.
Yeah.
And then I feed less protein, and the nitrogen. So protein is the carrier of nitrogen in the system. So with I replace that 50% of less nitrogen I put in the system by sodium nitrate. So an inorganic nitrogen source. So so in all the 6 treatments going from 190, 80 to 50, we give exactly the same amount of carbon and exactly the same amount of nitrogen to the system. And it's a biofloc system, so the shrimp grows. And when we harvest, we see that the production is the same in all 5 tanks. And so I did other experiments like that too. So we get, in a way, during our studies and by the practice of agriculture, we get a little bit of thought that we need to have very good feed to feed our animals. And in a way, that is true. But actually, the environment, that comes to your question, the environment also provides feed or nutrients for the animals. And so we don't use that capacity of our environments. And then your question
when you put the
Thank you so much for staying with us. So we already exceed actually the specified time. So now we are going to have a lunch. So the participant can take lunch in front of the building, but for the Wageningen University, you can take your lunch in the meeting room. Thank you so much. See you later in the session 2.
Punten mau minta presentasi yang itu tuh pemain itu. Makasih ya Pak.
Hari ini terlanjut saya di presentasi ini juga. Oh, yang di lapangan. Oh, sorry. Udah mulai jam berapa? Jam 2.
Hello? Hello? Hey, good afternoon, everybody. Welcome to the second half of this conference. This part is running at the same time as a shrimp section, so the room might not seem as full. But I think we get started. So my name is Logan Binch. I'm a PhD candidate at Wageningen University Research. My research focuses on operationalizing ecosystem-based fisheries management in Europe.
And let me introduce myself. I'm Kiki Syaputri Handayani. I'm a researcher in Research Center for Marine and Land Bioindustry. And I'm recently working about a mussel. It's like a Asian monoscallop. So I hope we can enjoy this event. For the distinguished speaker and participant, we will welcome you to the next session. This is the second session for this afternoon. We have 5 speakers. And the first, we will have from the Blue Revolution perspective of Netherlands and European Union.
Yeah. So I'd like to introduce Geert Wierstes to the stage once again. He'll be presenting the Blue Revolution from the perspective of the Netherlands and European Union.
Tadi mana? Tadi yang putih.
Okay. Yes, welcome again. I would like to start with asking our chair to pronounce my second name again. Okay, my name is Geert Wierstes. You can practice it on it in your hotel room. I was asked to give a little bit of insight on aquaculture in Europe. And I'm giving you a pamphlet of the European Union and how the European Union, how the European community looks at the blue economy. And no, I don't have a pointer. So basically, you see beautiful numbers, how important the blue economy is for Europe. I think what is most important on this slide is the reference to the Green Deal. And the Green Deal is the initiative in Europe on which we focus our future and say what we have to produce, when we produce food, it has to be in a sustainable and nature inclusive manner. And that's very important. And we apply this also to any form of agriculture and fisheries, so to the blue economy. And you see these 2 bars, that's a windmill. And you see the bar that represents the number of windmills that we will have in 2050. So the number of windmills, especially in the North Sea, is going to increase enormously. And that will have a huge effect on what we do in the North Sea. The other point that has a huge impact from the European perspective is the strive for biodiversity and my marine protected areas. Yes, they're there. And the political decision in Europe to install at least 30% of the area of our seas and oceans as marine protected areas. So basically, if you look at the North Sea, I had a map and I threw it out there. But if you look at the map of the North Sea, and basically what we try to do there is we try to do fisheries. We try to produce energy with windmills. We try to have a route into the main harbors of Rotterdam and Antwerp. So there's a lot of activities in the North Sea, and we can't do it all at the same time, which also means that we will not have aquaculture in the North Sea. Not only for that reason, but it's not something we do. Basically, it is too intensive already. If you look at aquaculture, there's also a new 5 or 10 year perspective for aquaculture formulated by the European Union. And you see a number of pictures. You see seaweed. And I was just having the discussion over lunch. Indonesia is the biggest or the largest seaweed producer in the world. The Netherlands is stimulating the production of seaweed, and I really do not know why. If you produce so much seaweed, I would say send it to us if we don't build it. So it is considered a, let's say, a green form of aquaculture. In the Netherlands, we call it road traffic aquaculture. We produce some of it. It's not very productive yet. And to be honest, it's very difficult to sell because we don't have a traditional dinner that includes seaweed. But seaweed production is stimulated. You also see the bivalve production being stimulated. We also see this as a form of aquaculture that will grow in the future. And you see the fish still connected to the windmills. I'm not sure why they're connected to the windmills. We're having discussions because we want to install marine protected areas that are windmill areas could be accepted as marine protected areas because they would allow fish to grow undisturbed and create biodiversity. But that's debatable. Yes. So that is a bit of background from the European Union. If you go back to our university, then I think what is maybe relevant for you, because I always say if you want to do something with aquaculture in our university, it's quite difficult to find people. Websites traditionally are not meant to find people and what they do. So if you want to try to find Mark Velken on our website in time for the university, or you say, I want to find somebody that knows everything about aquaculture, it's quite hard. So we installed an initiative regarding Aquaculture Research and Education. And what it does, it's across Wageningen University and Research program. And it combines all the university chair groups and all the research institutes in Wageningen that are interested together in making aquaculture more sustainable. And if you go to this website, it will give you an opening to different themes. And in all these different themes, you'll have different people working together. So we may be the largest group, all of us focusing on aquaculture. But there's also other people in the university that work on environmental policy that have different expertise with an interest in aquaculture, and they can be found on this website. So that may be useful. So what does aquaculture look like? If you look at the global production, you see this is the animal production and this is the plant. So this is basically seaweed, and then probably most of it is again in Indonesia. If you dissect this out to animal production, And you see worldwide, you see most is finfish, and followed by mollusks and by crustaceans. So finfish is still in the animal part of the aquaculture production is the largest, but you see how important also seaweed is. If you compare Asia and Europe, it's very different. So in Asia, finfish production is enormous, and that's inland compared to the marine. So in Asia, and especially China, of course, contributes a lot to this. It's mostly inland aquaculture. If you go to Europe, it's completely the reverse. Of course, the numbers are also slightly different. So we're very proud of this number 3, let's say, it's the 84% reaches 3 million metric tons. I mean, here you reach 50. So the numbers are completely different, so that's a big difference. But also the inland versus marine is completely different. So if you summarize this quickly, if you look worldwide, then on the inland aquaculture production is mainly crabs, tilapia, and catfish, and it's made mainly in Asia. In Europe, yeah, why is it more marine? We say because we like marine fish species more. That would be the reason. Yeah, maybe that is the reason. We have in Europe, we have landlocked countries, so the countries that are not bordering the sea have a traditional form of aquaculture, usually on carp, but the species is a bit less popular in Europe. And you see that the regulations so far for the marine waters have always been a bit less stringent, but it's increasing. So you see, especially in Norway, Norway is a country where there's a lot of aquaculture. You see the regulations on the environment becoming more and more strict. If you ever find numbers for Europe, or sometimes you find very nice video clips of the European Union on aquaculture in Europe, be aware that when they talk about Europe, they often exclude Norway and they exclude the UK, because they're also the UK is out of Europe. Whereas the larger producers of salmon are in Scotland and in Norway. So you get very strange numbers sometimes if you look at Europe. I added these because this is a bit about what we want from aquaculture in the future, or what we want from our food systems in the future. And these are a number of points that we say these are important for our future food systems. So we realize that at present we have a food system very linear and has an enormous environmental impact. Whereas we should be shifting towards a more circular system. We also realize that nutrition is not only determined by food availability, but also by food utilization. And in the future, we should avoid feed-food competition. So we should compete, we should avoid the competition between something that we can eat ourselves and something we feed to our animals. I'll come back to that in a second. We should also realize that if we think in animal use, it's not only to eat animals, but animals are also used for other purposes. And this is one point that is becoming very important in Europe. We more and more have a different perspective of animals, and there's more and more a generation that is growing up and saying, I don't want to eat animals. So the perception of how we keep animals and whether we can or cannot eat animals is changing. And associated with that, we are more and more aware of the welfare of these animals that we keep. So we're discussing these days, instead of linear systems, we're discussing a lot of circularity systems, circular approaches. And there's 5 principles that link to circular approaches. You safeguard your ecosystem, you avoid waste, you prioritize food over feed if you can eat it as a human why would you feed it to an animal? You recycle your byproducts and you reduce the energy use. Those 5 principles have been formulated as the principles of circularity, and we're having whole discussions on what circularity now exactly means. The easiest thing to remember is sustainability is something you can never reach. It's a long-term thing, it's endless. And circularity is a method to become more sustainable. I think that works best. So if you think in the prioritizing of food and feed, and I'm going to show you 3 slides of Anne Jo van Riel, and she's sitting there. So if you have any questions later on these 3 slides, she can answer the questions. We like to think in low trophic aquaculture. We like to reason that if you are culturing seaweed or bivalves or low trophic fish species, it is more sustainable on the long term than when you grow high trophic animals such as salmon and normal. But what do we do in Europe instead of in Asia? In Asia, you still grow a lot of tilapia, you still grow a lot of crabs, which are considered more low trophic. You see this beautiful line, and that's all marine fishes. It's all high trophic animals. It's all salmon, I would say. So we're not very sustainable from that point of view. So if you look at the trophic level worldwide, then it's actually not so bad, because you see the largest percentage worldwide is actually on the lower trophic level. But that's mainly because of the work in Asia, not in Europe. So you would say if you maintain what you're doing, you're in some respects more sustainable than what we are doing. So if you then think in feed for competition, Anna, you're smiling all right. Well, it's a beautiful graph. That's because she made it. If you think in the diet you give these animals, then we tend to give a lot of feed to these animals that we can also eat ourselves. And it's a bit more complicated than that, because it depends very much on whether we really can eat it ourselves. So in this graph, we realized, or we didn't take into account, that we potentially can eat the meal in the fish bowl ourselves. So it depends a bit on how you look at the ingredients of the diet, whether we consider them suitable for humans, because we can upgrade a lot of the ingredients we give to animals such that we can eat them ourselves. So it depends a bit, but this is the more simple one, where salmon is a species that would consume a lot of ingredients that we could eat ourselves, whereas carp and tilapia are animals, fish species that would not. But the overall message is a bit more subtle, but I'll leave that to you. If you want to know more about that, what I already mentioned, then read this paper. Soon, and that may be of interest to you, I showed you the 5 principles of circularity. We're writing a summary where we apply those 5 principles of circularity to aquaculture. Almost done. And that paper should be out in a few months, I hope. So that may be a nice paper, because that forced us to think a lot about how we design a food system of the future in a more circular or sustainable way. And now I have to talk 5 minutes more. No. Thank you.
Okay, thank you very much for Professor Kurt. We Kurtis. I try to spell your name. Okay. The second speaker we will have Professor Dwi Listio Rahayu. She is a professor in Riset Center for Marine and Land Bioindustry. So we will discuss with her about exploring Indonesia's marine biodiversity, especially in taxonomic research and joint expedition. For Professor Yoyo, the time is yours.
Good afternoon, ladies and gentlemen. My name is Dwi Listio Rahayu, but just call me Yoyo. So today I will talk about Indonesia as a mega biodiversity spot. And I choose crustacean taxonomy. Why? Because crustacean is the second most diverse and abundant in the sea after mollusks. So when we talk about Indonesia as a biodiversity spot, then we always say about where Indonesia is lies between Pacific and Indian Ocean, and we have a deep sea and shallow water, and we have a very long coastline, and we have all kinds of the habitat for marine organisms. So we also talk about coral triangle. So when we talk about coral triangle, Indonesia is in the center of a coral triangle. Here we can see that is a hot spot for marine biodiversity. Exploration Indonesia, because it's a rich marine biodiversity and very famous with all kinds of biodiversity. And we have all kinds of expedition. This is the expedition, the time of colonial time. Sorry. We have here Siboga and Snellius. This is a Dutch colonial. And even the material of Siboga, I still work with the material of Siboga after 100 years. And this is after the Independent Day, we have some of expedition international. And this one is Alpha Helix is with Australia, Corindon, and I think, yeah, Corindon and Karubat is with France, Snellius, of course, is with Dutch, and Anambas and South Java Deep Sea with Singapore. And here LIPI, that is now is BRIN, is also conducted with Vidya Nusantara since 2007. But still the remain question, how many marine species are currently described, and how many marine species are recorded from Southeast Asia, and how many species marine species recorded from Indonesia. Here is marine species distribution. I took it from, I think, this is about, it's not exactly the number, and here I took only the big group of marine animal. Then we can see here crustacean, mollusks, and fishes. And fishes is a biggest species that already recorded. When we talk about Indonesia again, here in the west side, we have shallow water. Here, it's about shallow water. and then the north, the south, and the east is mostly deep water. Up to now, we still discover a lot of new species. And here is the coastal or shallow water. We have all kinds of habitat, mangrove, and here is reef flat, coral reef, seagrasses, and mud flat, and that. And to find, to discover the biodiversity, we still have to go to places that no one go before. So here is the deep water. We have also clear, hydrothermal, abyss, and simon. Simon, we discovered that in the north of Sulawesi, we have a lot of simon and hydrothermal. And to explore and find, we have to go places that no one go before. This is about the deep sea. And this kind of habitat, nobody wants to go there because it's very dirty. And then, and this is the big mangrove area in Papua. And you get lost. Here is how we collect in littoral and supra-littoral. This is in the north of Halmahera, and we collect by transit and by just breaking the coral. It's not coral, dead coral, and also picking from the sea, and also we use this yakapa. And this is for sub-littoral. We collect with small probe, small dreads, and also brushing coral and sucking like this. Then we do this in the expedition, land-based expedition. I mean, it's not in the ship, but the expedition that we do from the beach. And when we go to the deep, then we need ship. This is explore the deep sea is very challenging. We have to have a good research vessel. We have to have a good equipment, and we also have to face the rough sea, and also how we get seated for the night. And that's we also have to see the time. The time here, I mean season. We know in Indonesia, if you want to go to the west side, you have to go in April, May. If you want to go to the south, then we have to go to February, March, April. But when we want to go to the east, Maluku, Papua, Sulawesi, then we have to go in September, October. September, October, the sea is just like a mirror, very because if we go when the sea is sharp, we cannot employ this kind of this equipment. Then we need a calm sea, then we put it down and then just dredge the bottom of the sea. And something like multi-core, we can employ, depending on the cables, and we can employ up to 2,000 or 3,000 days. And you can imagine what our kind what we find from the depth. It's very interesting. And here, during 10 years of Census of Marine Life, the program of Census of Marine Life, we people describe about 1,200 new species of marine animals. And this is the when is it the last Census of Marine Life, and then it's still up to now still we discovered a lot of new species. This is the fish from Indonesia, and this is the shrimp from Lombok, hermit crab from Ambon, and this is from Sulawesi. And this is also the new species from the last deep sea expedition in 2018. We have 14 days at sea, And we find 27 new species. We collected about 20,000 specimens. And this is what we have. This is very interesting. The big giant isopod and very tiny fish, and the unique hermit crab in the solitary corals, and the very big sponges that we find from all the deep sea. And this one, when we put in the water, they are just moving like that. It's very interesting. And this also the species that the type locality is in Indonesia. This is mostly come from the east of Indonesia. Yeah, from the mangrove area. This one. Only this is from the coral reef. This and this is from the coral reef. And this is again the new species with the type locality in Indonesia. And this one is from Lombok. Yeah. And we have too many species, too many, few experts, filter time, too many problems. Yeah, this is all the hermit crab is still in the shelter. The shelter is a shell. Yeah, and this one, when the hermit is out from the shell, that's beautiful, huh? And this one, the crab, it is all come from the line, pearl oyster line behind our office there. And even this, I don't know what is this. So I only can say this is a Philomnidae, this is a Santidae, and Talmidae. But what is the name? And this is another creature from the deep sea. There's a worm and also solitary coral. This is solitary coral, and this one a foraminifera come from the 2000 Baltic core. And this all kind of the crab. This one is the new cucumber. They're not described yet. And this is the strange fish. But look like it's a big, but it's just very small. Well, yeah, you can say that the science is global. No country have all experts to work on their biodiversity. Need cooperation, and to know and understand the species, we have to know what is elsewhere. Cooperation is needed. Networking is a must. I can tell you stories. We know about this blueberry hermit crab. Is already in trade for several years, but somehow we know that this is not the known species. But we are not so sure because the color, this color of this hermit, I mean land hermit crab, when they are small, they are white. They are a bit bigger, they are red. After that, they are green, they are blue, they are purple. So we need to see layer from many other places. So when our colleagues say, let's check the molecular. Okay, let's check the molecular. And then we check the DNA, and then we know that this is a different species. This is a different from any other hermit. And then we try to find all kinds of species from another place here, from the Indian Ocean, Madagascar, Mayotte, Thailand, and Japan, Vietnam, and Taiwan. And then after that, okay, we are sure that it's a new species. described is morphologically and molecular. The study started 2010 and published only in 2016. And the second story is the case of subject complex. We find this specimen here in Lombok 79. And then after that, I don't know because Pita Muda, Brachyura, very often have a 10 leg, and here is only 8 leg. The family is our one species. And then I went to the museum in Singapore. I said, what is that? And the colleague there showed me about.
Excuse me, Professor.
Okay, this is the same group of the species. And we start to look, and then we see, and so on and so forth. And then try to see from all other places here. And then finally we find that group is 3 genera and 18 new species from Africa, Australia. Started work 2009 and published 2014. Okay, these are only possible because we need to access to the collection in another country, in another museum, and also working with another colleague. And yes, we need the collaboration. I think this is my story. So the marine research strategy to discover biodiversity in Indonesian water or in any other waters, we need the cooperation. We need a networking, capacity building for young scientists, and also reference collection supported by molecular DNA and campaign on the importance of deep sea biodiversity. Thank you.
Thank you very much, Professor Yoyo. Actually, we already told you that we have still 5 minutes left, but you already made it finish very well. So, actually, do you want to try? Okay.
Okay, next up we have Dr. Ferurozi. He's a researcher at the Research Center for Marine and Land Bioindustry at BRIN. And he'll be giving a talk entitled Optimization of Indonesia's Aquatic Biodiversity through the Global Bioindustry.
Okay, thank you, Pak Roroti. So basically, I'm not so going forward with the optimization of Indonesian aquaculture biodiversity from the blue bio industry, but also want to introduce what is a BRIN exactly, and also our research facility here in BRIN. Okay, so this is our research organization in BRIN. We are quite big right now, so we total about 15,000 of researchers, and then we are belong to research organization of Earth Science and Maritime, with the total of researchers is about 1,100 researchers. So, and we are here in the, okay, say, okay, next part. Yeah, this is exactly in the research organization of Earth Science and Maritime. We have several campus here in Indonesia. First one is the headquarters in Jakarta, in Laterio, in Ancol, and then we also have a campus in Jakarta, also in Fiery Island, and also we have here in Lombok, Marine Bioindustry, and also we have a center, Deep Sea Research Center in Ambon, in Maluku, and also for genomic research we have in Cibinong. Okay, yeah, this is basically I'm a research center of marine and inland water bioindustry. We have 5 research groups. First with marine research convergence. We have also the bioproduction of potential aquatic biota, and we have the diversification of process product and also utilization of fisheries byproduct. We have aquatic microbiology and biotechnology, and also aquatic natural product. And then the campus concerning the marine, we have 3 here. So Research Center for Fisheries, Research Center for Marine and Inland Water Bioindustry, Research Center for Oceanography, and Research Center for Deep Sea. Okay, so when we are merger with the other institutions, so we merger with at least 5 research institutions in Indonesia. So the first one, I think, from the Research Center for Biotechnology from the Ministry of Fisheries, and also the Research Center for Product Development, also from Ministry of Fisheries, and we also have some research staff in Bali, in Gondol, with the Research Center for Aquaculture, and also from Research Center Aquaculture in Lampung. So the headquarters here in Lombok. So we have quite a lot of staff, but not in Lombok exactly. We have in Jakarta and Lampung, and also in Bali. So this is some of our facility here, and then this is our sea, we call it sea laboratory because we are very close with the sea. Here we have floating net kit. We have also a long line we can use for field research, and also for seaweed normally. Okay, next. So, and this is also you can see after this symposium, we have aquaculture laboratory with a lot of boxes with the big capacity for 4 tons, and also we have the small aquarium, and also yeah, the control system directly from the sea. Yeah, we do here some small research exactly concerning the microalgae and also macroalgae. We have 2 kinds of macroalgae. First one is Ulpa lactuca and also the colepa, but we still do in the small scale of research. And also we have several kind of microalgae for aquaculture. Okay, and this is some of our research facility. We call the Laboratory of Characterization. We have SPLC, we have GC, and also multimode reader, and you can also visit this today. And next. Yeah, this is our co-working space. I think in the second laboratory, you can visit our building.
the next building, I think, is quite comfortable if you can stay here to visit and just working in this facility. And this is also the view of our office in the sun side, but maybe you're just waiting for 5 p.m. I think you can see this one in behind you. Yeah, this is the idea how we can build this research centers here. So basically the idea is how we can build this aquatic biomass, so like microalgae, macroalgae, and also fish, and also fish byproduct. And this was made by Program as circular bioeconomy, something like this. And then we cultivate this aquatic biomass, and then we study concerning the bioprospecting and also bioprocessing, normally with 2 fish with the post-harvest technology, and then we also do with the bioprospecting and processing to produce some food, and also from secondary metabolite and others benefit for a human being. Next. So this was research what we do before is first with pear oyster, and we also do research with the sea cucumber. We have also abalone, black sea cucumbers, and other research. And next. And this was maybe now interesting for us here in West Nusa Tenggara, especially for algae, because we have a lot of shrimp farm here in Lombok, but mostly the hatchery, they don't have facility to cultivate the algae instead. And normally they do with the open facility, and sometimes they have contamination for the environmental. And then I think we need to do how we can cultivate this algae with sterile condition, and also the technology for the harvesting. And yeah, West Nusa Tenggara is also very big potency for seaweed. And then we still have the problem right now with the seed, because we have a very bad condition of seed, and there is no continuous of seed in Lombok. And also post-harvest technology, we also have problem, and also the drying technology with less facility for drying. And for lobster itself, we have a lot of the seeds, but we have limitation in the feed. So there is no feed available exactly here in West Nusa Tenggara. Mostly we send from the Java, from Surabaya, and so on. And also from shrimp itself. So we have a lot of seed also here in West Nusa Tenggara, but we still have problem with feed and also disease. I think this some kind of research. I think we can conduct together with BRIN, and also for future collaboration with other country, also with WUR. So this is just some example. I take this picture from the Alpen House in Hamburg, and yeah, we're still thinking how we can build this facility, because BRIN something they also build some facility, but yeah, we try to imagine to how to cultivate the microalgae, for example, especially for marine microalgae, and then we can use for superfood production, or for pharmaceutical, cosmetica, and nutraceuticals. So, and for seaweed itself, we have in West Nusa Tenggara, we have very big the potency of seaweed. We have about 677,000 tons per year. So this is the biggest seaweed production here in Indonesia. And this year, I think West Nusa Tenggara will become the national research center for seaweed, from the aquaculture to the final products. Yeah, this is also for seaweed itself. So we have the very big potency of seaweed cultivation here in Lombok, exactly in the Grupuk and also Awang Bay, and also from Ekas and Sereweh Bay, we have total with the Sumbawa Island, so we have about 12,500 hectares, but now we just use about 10,000 hectares. So we have still a potency to cultivate seaweed here in West Nusa Tenggara. So this is the distribution of seaweed here in Lombok. Normally we have 4 types of seaweed. First one is the Potoni, and also we have green sakul, also we have spinosum, and also glaciaria, and mostly in middle of Lombok and also east of Lombok. Yeah, and for the seaweed itself, we still have some problem with seed, because we don't have a lot of seed available here in West Nusa Tenggara. Mostly there is no seed with the tissue culture. I think if we can have the tissue culture technology for seaweed seed, I think it's more important for us. And also for the post-harvest technology, there is no, for example, selection between the dirty thing, plastic, and other when they only do like this and then sell to the company. And also drying process is not sterile, and we only do in the land, something like. So, and this is concerning the lobster. We have one village here in Lombok called the Kampung Lobster, or seaweed or lobster village, something like this, and it's very big, the potency of lobster here in Lombok, but yet we still also have some limitation, especially in the feed of the lobster. So I think there's some opportunity to do our research is unlimited natural supply of the lobster seed, and shellfish farm, and also pellet manufacture to support the lobster aquaculture, and also we also expand of the sustainable growth outside and corporate investment of the lobster farm here in West Nusa Tenggara. Yeah, this is also some opportunity from Dr. Bayu. So there is several opportunity for us, especially for feed of lobster, because now it's feed is very rarely here in Lombok, but we have a lot of seed, but we less in the feed for the lobster. Yeah, and this is the potency for shrimp is set in West Nusa Tenggara. So from 2022, we produce about 159 tons per year. This is the biggest shrimp production in nationally, and West Nusa Tenggara also have a big opportunity to cultivate the shrimp. We have about 27 hectare, and then now we just use about 500 hectare, and we still need to educate the people how we can put aquaculture for the shrimp. Yeah, and this is some opportunity to us, I think, to do some research, and then we still have also problem with the seed, and also for disease, and also the biosecurity for the environmental, like the waste of shrimp farm. It also with a problem right now, and explosion the ecosystem is just balancing with the good technology. I think from the house, I think they use good standard quality. Okay. So, and yeah, this is some example. Also, there's some problem here in Indonesia. I think we talked earlier with Prof. Gert that aquaculture is also something different with tourism. So because in one side here we call the Untuk Bay, so we have also surfing spot, and also inside we have a seaweed cultivation, and most of our fish farmer now moving to the tourism, and then they don't do aquaculture again. So this is also some problem we need to resolve here in West Coast Secara. Okay, and this is some kind of how we can do the collaboration with the BRIN. We have the program from BRIN, so called visiting researcher. So if you have interesting in to do research in our research center, so you can apply for visiting research and also the postdoctoral. We still can open this opportunity to collaborate. Okay, we also have matching funding. So if we have good proposal, so we can also fund for our research, and we also have another opportunity for funding the research by expedition, and we have also the research for exploration. Yeah. So the deadline for visiting researcher and postdoctoral for 31 of July. So if you are interested, we still open the opportunity to join our research collaboration here in Lombok. Thank you. Okay, I think that's all. Thank you.
Thank you very much. The head of Research Center for Marine and Land Bioindustry. Okay, the next speaker, we will have distinguished speaker, Dr. Devi Dwiyanti Suryono from Research Center for Conservation of Marine and Inland Waters Research from BRIN. We will talking about aquatic biodiversity conservation effort in Indonesia. For Dr. Devi, the time is yours.
Thank you, Bapak and Ibu Moderator. Thank you, Mbak Kiki. So, good afternoon, everyone there. So, maybe please allow me to share. The committee will share the. Okay, please allow me to share the presentation.
I'm sorry, Dr. Devi, could you please make it louder for the sound or your voice?
Okay. Sorry. Maybe I will turn on the camera during the presentation due to unstable connection here. I'm sorry. Okay.
Ada problem apa, Bu Devi?
Can you hear me?
Yeah.
Okay. So I will turn off the video because the connection here is unstable. Thank you. Hopefully
to PowerPoint mode. I mean
okay.
presentation mode. Okay, thank you.
Okay, thank you for this valuable opportunity for me here to share with all of you about coastal ecosystem conservation towards protecting aquatic biodiversity. As we know, Indonesia is one of the 17 mega diverse country in the world wide. So the species diversity already mentioned by Professor Yoyo, how much diversity of species in Indonesia. So Indonesia has the highest in the world of endemicity, and Indonesia also conservation area with covering area 5,154 for terrestrial protected area, and for marine protected area Indonesia has 196 marine protected area. And for ecosystem diversity, it is known that around 74 types of ecosystem can be found in Indonesia and create very complex formation that including marine ecosystem. And also genetic diversity, also already mentioned by Professor Yoyo in previous presentation. So this is the coastal ecosystem in Indonesia, such as mangrove. Mangrove in Indonesia is the largest area in the world, with covering area of 3.3 million hectare, and then seagrass with covering area 3 million hectares. Coastal ecosystem in Indonesia not only have a large area, but also provide ecological services. As we can see in this slide, coastal ecosystems are highly productive that are particularly important for their capacity to store carbon within the plants and in the sediment below, and also provide various ecosystem services, include protection of coastal habitat, which serve as feeding and nursery ground for fish and shellfish, and then protection of coastal infrastructure from storm surge and flooding, as well as provision of water purification. Certain seagrass species, one of coastal ecosystem in Indonesia, such as Thalassia hemprisi, Halodule uninervis, and Halodule pinifolia are associated with the presence of turtles and dugong. The three seagrass species are the main food for that endangered animal. So in this slide illustrated the activity surrounding coastal area. Coastal area have important role for some activities. So various activity mostly in coastal area, such as industry, tourism, agriculture, coastal reclamation, marine transportation, and etc. But so the existence of coastal ecosystem is known to continue to experience degradation, especially due to anthropogenic activity. The anthropogenic activity already mentioned that the population growth need settlement, and the settlement need land use change, and the other part of anthropogenic aspect will decline of coastal ecosystem. In this slide, we can see the seagrass condition. There are burning condition and also macroalga sargassum. This condition indicated the high nutrient load in that area. And this slide, the condition of mangrove is a degraded condition of mangrove. So declining of coastal ecosystem could be treated for aquatic biodiversity that caused by declining of fish abundance, loss of ecologically important and iconic species for tourism development, such as sea turtle or green turtle in certain area, and then sedimentation and loss of nursery and feeding habitat, and also declining of water quality. This figure saw that the coastal food cycle that its component are interconnected each other. If one component decline, it will impact to the cycle food, and finally the biodiversity will lose. This is the impact of the exploitation of coastal ecosystem. And in this slide, we can see also the connectivity of coastal ecosystem between mangrove, seagrass, and then coral. The connectivity of coastal ecosystem is very important to its function. Maybe I can give you the example. If the runoff from the upland area come to the coastal or to the estuary area, will affect turbid water in coastal area if mangrove or seagrass and coral were degraded, because the function of filtering the water is not optimization conduct implementation. So based on the decline condition of coastal ecosystem that will be impact to the aquatic biodiversity, some efforts are conducted through research activity and policy. And this is the research focus in our research center. The research focus on conservation on habitat, and then in the species conservation and genetic conservation. There are activity for conservation of coastal ecosystem in research group of blue carbon, and then spectra activity, and for conservation ex situ and domestication for the species, for species conservation. Another activity, we already installed one cage in Derawan since August in 2019. For the research focus on the effect of turtle grazing on seagrass ecosystem and its potential for regeneration and restoration. But this activity already postponed due to the pandemic situation, and the project already finished in last March. So we still we're still waiting for another collaboration or another funding to continue this research activity. And another activity to identify the conservation effort is try to inventory of coastal ecosystems such as mangrove and seagrass in some area in Indonesia, from west Indonesia, center of Indonesia until the east of Indonesia. And the data that we got can be determined for conservation area in Indonesia, and also the biomass for its coastal ecosystem. Another opportunity for research activity is develop sustainable aquaculture model. There are two models maybe will be developed in near future about the smart aquaculture already implemented in stream aquaculture in some area in Bangka, Lampung, Indramayu, and Banyuwangi. Hopefully in the next location will be implemented also. And then the second opportunity research activity is climate smart stream. This activity is stream aquaculture that will leverage the aquaculture sector to reduce environmental degradation and restore ecosystem in ways that can access investment capital and scale restoration. This is the opportunity for aquaculture research. And another effort is from our government. Government of Indonesia has committed to set aside 20 million hectares in year of 2020 of its coastal and marine environment for conservation purposes. And this activity starting from year of 2019, develop a national marine protected area system based on management effectiveness. This is the map of conservation area in Indonesia. From the data is from Ministry of Marine Affairs and Fisheries in 2022. There are 28.9 million hectare the conservation area in Indonesia. So we hope that the conservation area will be added to get the target in 2030 for 30 million hectare. And this is the review of existing condition of distribution of conservation area. There are increasing of coverage of ecosystem conservation in this year. For ecosystem, mangrove and seagrass, the data indicated that still under 30%, still under the target. Hopefully in the next year, the conservation area will be increased. And the increasing of conservation area need the data from the research activity. So this is the last slide. In the future, there is a great potential to establish a protecting area, integrated coastal management, regulating and preventing marine pollution, ecosystem-based fisheries management, and also enhance collaboration and capacity building to develop a science-based policy for coastal ecosystem conservation toward protecting aquatic biodiversity. Okay, thank you. Terima kasih for your attention. Thank you.
The final presentation to answer any potential questions. So last but not least, I'd like to invite Donne Matthijssen to the stage. So Donne is a PhD candidate at Wageningen University Research, and he will be presenting fish migration in a novel ecosystem. Time is yours, Donne.
Nowadays. Okay, cool. So yeah, thank you everybody for sticking around after this long day of talks, and hopefully I'll be able to tell you something new that we didn't discuss yet today. I'm going to be telling you something about how I'm studying fish migration within a novel ecosystem and what actually I'm referring to by the term novel ecosystem. But first, why fish are relevant? Why am I studying migratory fish species? Well, firstly, because fish are the most diverse group of vertebrates, so there is a lot related to them in terms of challenging the biodiversity crisis going on at the moment. But other than that, if the slides are working. Yeah. There's a worldwide decline going on among all continents in terms of decline in fish populations, with Europe being most heavily impacted, losing 93% of its original diversity compared to the 1970 baseline. And other than that, fish are also being used as an indicator species for the ecological state of European rivers, especially in the Water Framework Directive, which is a European initiative to assess the state of the European surface waters, so that there be both criteria for ecological needs, but also for human needs. But other than that, they also drive the diversity and community, obviously, of the fish species, but also other species that are dependent on to complete the life cycle by functions that are fulfilled by the fish species. And also the abundance of species might influence that. And a big factor that has caused this decline are migration barriers, which are pretty much just physical blockages that prevent fish from migrating upstream or downstream. This picture is unfortunately not from the Netherlands, but it gives you a good idea of what the fish might run into. This is a picture from the Netherlands, another type of barrier which is aware, which overflows, but we use it to regulate our water levels, as the Netherlands is quite a unique system in terms of that we are part of a land laying below the sea surface. So in case we do not regulate our water levels, we get very wet feet and possibly also wet shoulders. We have culverts, which are now being recognized as becoming a barrier as well, which is why we are also redesigning them, which actually emphasizes the attention that it's gaining now over time. Oh, that was a little too fast. Just to give you an idea on the amount of migration barriers that are existent in the Netherlands, every little dot is a migration barrier that has been solved, which is applied by the green dots. Yellow dots have a planned solution for them, for fish to bypass these areas. And the purple dots actually indicate that there is no solution found for them yet, which we are still considering, which is dependent on many factors to include. Not only in the Netherlands do we encounter these. Yesterday night, I took a quick search on Google Maps to see whether I could find any migration barriers in Lombok. It took me 2 minutes, and I found this one. I'm not sure the purpose of this one, but it did not appear to have any migration facilities. So there's also some work for the people around here. So in case you're interested after this talk, please hit me up and we can discuss. But other than the migration barriers, there's other factors going on which led to the degradation of habitats, which might also be implied by the migration barriers themselves. But we, especially Dutchmen, we modified the run of our rivers, which means that we canalized our streams, which means we took out all the little curves, which gives some diversity to the area and straightened them right out for human purposes, navigation purposes, transport of different kinds of goods. We also discharged all of our waste into the water, which led to foaming of the water, reducing the oxygen content, depleting the entire fish stocks, and thus also our native migratory fish populations. To give you an idea of what this looked like at its worst state and/or best state, in 1822, when we did not touch the system yet, it was a nice curving stream. This is just a subsection of my study area, so to say. Whereas in 1980, it was almost a straight line. And you can imagine that in this straight line, we are losing a lot of diversity, which might have offered the right type of habitat for fish to spawn, grow up, or whatever they needed to fulfill their life cycle. So what we're doing now is mostly restoring these rivers, and we do that with the purpose of the fish being able to fulfill their life cycles again. But we do that just from an intuitive thought, and now we want to study what actions are actually making the right benefit for which species. So what we do is we bypass the physical barriers or we remove them. We do that by fish passages. We also supply side channels, which offer a different type of habitat compared to the main canal, which we cannot always remeander, which is another type of restoration method I will discuss shortly. But that is also to offer the right type of habitat to the fish species within the canal basin, so that they do not necessarily have to bypass it completely. We do see that there is being made use of these side channels by young fish swimming in them, which means that they are actually using these areas as spawning habitats, as the spatial range of this life stage is not that far yet, maybe limited to a few tens meters, something like that. And we're remeandering the streams that we once canalized. So first we straightened them out, then they were curved, we straightened them out, and now we're making them curved again to offer the diversity and habitat that they once was. So about novel ecosystems. Ecosystems are subject to change throughout history, which is a natural phenomenon. But the rate at which a lot of changes are currently going on are the influence of humans. And that is an essential aspect in the definition of novel ecosystem as stated by Hobbs et al. In 2013. And after these changes, the ecosystem must be able to maintain itself in its current state and have some self-organized abilities. That is an essential part of a novel ecosystem. Still, this is heavily subject to discussion and all that, which I will not dive into too much right now in this presentation. But if you want to do that afterwards, also very happy to do that. A bit more on how a novel ecosystem reaches its state. We have several states. So we have the historical state, which we're often referring to as in where we want to go back towards. But because of all the human interferences, removal of species or certain structures that we're offering the right type of habitat, we might change to its stage, which can be, like I said, by the addition or removal of species. So we can lose native species or use invasive species, but we might also change the habitat. And that's what is shown in the right top graph. And to go back from this novel state to the historical state, we might encounter barriers. And you might actually find that you're not able to reintroduce or bring back the species that is lost or has gone extinct because there is a certain criteria not met, and that you will have to look for species that fulfill the similar processes. So that's what we call that you sort of transplant a similar function, whereas you're not actually reintroducing a species that was once lost. And a result of that might actually be that we find that restoration back to the state that we're often referring to might not be completely possible, and that we will have to settle for an alternative state, which is not what most people like to hear, and especially governments, because they are often referring back to these nice romantic images that were once taken from the past. But to raise that awareness that this is a thing that might be the result of your restoration project is very important to stress. So about my work, it's in the northeastern part of the Netherlands. This is a more detailed image of it. And this area is quite interesting in that it is a miniature stream basin, which can be split up in three major compartments, as in three major types of habitats. That is an estuary in the northern end, which is directly connected to the Wadden Sea, from where the migratory fish species will actually swim towards the freshwater basin. The freshwater basin itself lies below this top red line, to south of that, which means that in this inland waters, the water is flowing north. And then after the fish would have entered from the estuary, they will run into some channels, which are just very broad, stagnant to slow flowing waters. And further upstream, about 25 kilometers inland, we encounter a natural gradient where the water starts to flow again. More on that later. First, I would like to give you an idea of what these areas actually look like. So this is pretty much the area where the estuary and channels meet. So in the top end, we can see this area, which is the Dollard estuary, which is tipped by high silt, low, shallow waters, about maximum 20 meters deep, and very high mud flats, which fall dry at low tide. Whereas the channels, they are very wide, maybe up to 40 meters, sometimes even wider, and somewhat shallow, deep, depending on what your reference image is. Deepest point is 4 meters. And if we go further upstream, we reach the stream area, where you can see that there's a lot more diversity going on, with a lot of data and different kinds of habitat being offered by that. And also the waterway is a lot more narrow this time. So the study area in terms of the natural gradient that I was talking about, the stream gradient of the system, and then I'm talking just about the stream area. So remember, that is the southern end, so the last 30 kilometers of the stream basin. There is a stream gradient of 26 centimeters per kilometer. And to give you an idea, so that is this point. And if we move entirely to here, which is 30 kilometers, that's where we already meet the sea level. So that will be here, which means that this entire area that is green bluish, if we would not have had dikes, that's the part where you do not want to live, because that's when your house becomes flooded and all that, in case that they will break. But it also means that naturally the water wants to gather here, and we need to get rid of it over there. So that poses some challenges in terms of cues for fish species that use flow as an indicator of where they need to go. This highest area in the Netherlands, or this study area at least, that's a garbage location where we collect all the garbage. So there's very little variation in height. To make a comparison between the Netherlands and Indonesia, to cover a height difference of 26 centimeters, so we need to walk 1 kilometer in this area. And in Indonesia, it seems obvious, but you can reach that in 1 step. So just to give a sense of how little height difference there is. So within this stream basin, we've actually re-established the physical connectivity, which means that all the barriers that were once there are now bypassed. Fish are free to migrate. And now we are actually looking into what might be an invisible barrier that is still remaining and what did the actions actually yield. So can we actually identify a certain restoration method that has improved the population size or the migratory route for a certain species? It seems very obvious, but this type of data has never been collected in the field, and it's also fairly hard to study because you need to track individuals underwater, which was and is a challenge for many species and life stages. So to track these individuals, we have 2 telemetry networks. One of these systems I use mostly in the freshwater basin, which is the big telemetry part, which I will discuss a little bit more in a minute. And we have an acoustic part on which I will go also a little bit more detail in later. That's on the right side of this image, but that is mostly used on the dollar estuary. So about the telemetry part for PID, that is mostly a passive technique, which means that we implement a tag into the fish species. And after they have gained this tag, we can always detect them by the number at certain locations where we have an antenna placed. These type of tags have a detection ratio, depending on the size, whether you take the big one, which is about 2.5 centimeters in length, or the small one, which is 12 millimeters in length. The range depends a bit on 30 centimeters to 1 meter in an ideal situation. If they pass an antenna, we are able to detect them. And by the detection, it is stored at a local computer, which is then every day sent to a server, which means that I can actually check the data remotely, which it saves me some time in the field, although I still am there pretty much every week. But that is for locations where we always have power available. But sometimes we want to monitor migration also at locations where there's no power available, and we need to come up with some of the facilities or set to track them, which when we build these antennas, so these little frames, which you can also see here, that is where the fish needs to swim through. If it will bypass that frame, it is no longer detected because it needs to pass through the frame by the electromagnetic field that is existent within there, because that electromagnetic field will charge the copper coil that is within the tag, which gives an induction current, which that gives the power to actually read the data that is on the tag. So to make sure that they will actually pass through these antennas, we actually block off the rest of the waterway so that the fish have only option to pass through the antennas. We do that with cruise-spine sticklebacks, which is we say that a popular species as an example in the Netherlands, and also very important because of its ecological functioning. It functions as food for many other fish species as well as birds. But it's also an example that we often use to depict many examples in biology in high school. So pretty much any Dutch kid will have it. Also, this is the first fish most people catch when they go fishing. When we start tagging them, we start in winter because water temperatures are still low, which helps them to recover from the sedation. Because when we tag them, we sedate the fish briefly before we allow them to recover. When we do that, we have a big team with us. So we have one person constantly watching the fish at the time that they are sedated, which means that they tip over. He takes them out, gives them to the first person that is tagging the fish. There's another person registering all the data because we also take length and weight. And then there is a second tagger available in case we have many fish caught and we can work a bit more quickly. And all these tanks are aerated so that the fish will always have sufficient oxygen available. And then after that the fish are caught and they have gained the tag, within a minute they will be swimming around again. And as soon as they start to swim around by themselves, they go to a bigger container, but they need to have sufficient water available. That will actually improve the recovery rate. But we first put them in a glass bin with a little bit less water, so we can actually see whether they are breathing again quickly after the surgery. And this is what it looks like after an attack fish has been recaught after 2 weeks. So you can see a small, what do you call them? A small mark. So about the data of this year, we see that, so this is the most distant, but this is March, and this is middle of May. We see that as soon as water temperature starts to increase, we get a lot more detections at our station. So we see that the fish are becoming more and more active as water temperatures increase. But we also see is that most of this species is tempted to stick around within the northern end of the stream basin, which means that they are actually preferring the slow flowing types of habitat. Of course, these are some preliminary results, and we need to dive a bit more in depth to see where they actually would tend to gather within these areas. As for the acoustics, that is an active tag, so it has an internal battery which gives a beep, and that will then be detected by some underwater hydrophones, which are a lot larger, as you can see. They are deployed out at sea, where we will retrieve them every year. We've only deployed them at the start of this year, so I still need to wait for this type of data. But this type of telemetry has a detection range of a minimum of 300 meters, which is a lot more beneficial to be able to track them out at the estuary and where we cannot block off entire waterways, also because of shipping traffic, but also other logistical issues. Then finally, I'm also doing some fish sampling because we want to know throughout the year what species are arriving or trying to get into the freshwater basin from out the estuary. It may sound obvious, but fish migrate at different times of year, and we want to see at what times do certain fish species arrive and at what length classes. Like, do a certain length class arrive at an earlier stage than another. For that, we have a big flight, which you can see over here, and a big box at the end. And the box just gives the fish some space to swim around, because when we catch the fish, we actually want to have some time available for them to swim around and stay alive, because we also want to be able to return them, especially in case that we catch any of these tagged fish. Because for pit, the ticks are not that expensive. For the acoustics, you do not want to lose that many of them, as in one of them is already way too expensive to be lost simply by another type of your own research. And throughout the year, what we've been seeing, so this has been from September last year, we can see that we see certain changes. So throughout the winter, we were back catching anything. And it's the year repeated again, we could actually see that there was a certain pattern evolving. So we saw some waves coming in, so higher numbers of catches throughout the time, which indicated that we were catching in certain bursts. And when we actually overlaid that with the tidal wave, we could actually see that as we would have a spring tide, we would also be catching more. So there is some type of passive tidal transport going on, which means that the fishes are quite literally going with the flow to reach their destination areas, or at least some species do. This effect might be mostly driven by one species. And what we're also seeing is that the composition of the catch is changing throughout time. This is, again, some preliminary analysis with some pictures of some interesting catches that we did. And I will do some more in-depth analyses to find out what these phenomenon, or what is driving these variations in time. So that is a bit of my work, what I'm doing. And in case you have any questions or would like to discuss anything about this topic, I'm more than happy to do so. And that's that. Thank you.
Thank you very much, Donny, for that wonderful presentation. I'll ask you to just sit down at the front and invite all of the other speakers from this afternoon session up there also. And we can now take questions from the audience and online.
We have trouble. This mic is still on, but please, for one's own speaker, could you please say something from your mic?
Check.
Okay. Okay, clear. Any other questions in this room or for the Zoom? Okay. We have.
Thank you. I introduce myself. My name is Tatas. I'm from University of 45 Mataram. And to the point in my question is for Matheson. Yeah. Does the stress in the river affect the migration path of a fish? And how can this problem be solved by modifying the flow of the river? That's it.
Sorry, could you repeat the first part of the question again?
Does the trash or debris in the river affect in the migration path of the fish?
Okay, so if there is a barrier within the river, the location of that, whether that affects?
About the pollution.
Yeah. Okay, understood. We did encounter that. Like I gave an example. We initially started out within my study area with the fact that there was water being discharged untreated into the surface waters which led to the high degradation of oxygen contents and thus also to all your life within that water system. So what you can say is that, or what at least appears to be the case, is that your abiotics, so your abiotic conditions of your water and water quality is actually your first factor that you should have solved before you start to reconsider opening up any waterways. If you would open them up, you are more likely to actually expand your pollutants and actually also bring the damage to the other systems of the area. Thus, first you should solve that issue that is actually polluting these surface waters. If you would not do that, then I think you are more likely to do more harm than any good. So that is an essential part. And your second question was?
How can this problem, the pollution problem, be solved by modifying the flow of the river?
I would not try to solve the pollution by tackling the run of the river or anything like. I would try to tackle the issue at its source. If you don't do that, you are just trying to come up with a temporary solution, which is going to wreak havoc at any later point in time. So first try to see if you can identify where the pollutants are coming from and try to reduce the input and preferably just rule it out completely. But I can understand that this is fairly difficult to accomplish that, as especially rivers in Europe might run through different countries. And one of the cases that we might run into is that the lower positioned countries like the Netherlands or any coastal country might be dealing with the pollutants of another country. So to solve that, there is a lot of collaboration between countries needed, and to make sure that everybody is also sticking to these regulations is a very important part, and also a very challenging aspect of that.
So the key is the mindset of people in the riverside area.
Yeah, that is a very important aspect, and also people that make use of that. So fishermen that are going out on the river by boat, that they simply, if they have any waste or any byproduct of whatever they do on that ship, that they keep that within their ship and discard it in a proper way rather than just discarding it overboard.
Thank you.
You're welcome.
Yeah, my question actually addressed to Prof. Yoyo. So thank you for your presentation. It's really amazing. And I love seeing like amazing deep sea creatures in your presentation. But my question actually is, how is the procedure to register the new species, I would say? Because I believe you need to submit it to somewhere. So yeah, people can recognize, oh, this new creature already registered, for example. Is there any kind of procedure that you need to do before go to the public?
Thank you. We can say there is a new species when it's already published. So we say this is new species, and how to prove this is a new species? Then we make a publication. And before we make a publication, of course, we have to describe, we have to compare, we have, if it's necessary, we have to check the type from another from the museum, and we have to check all. If it's in one genus, we should check all the closest species of this genus, and then describe it and publish. Then we say this is new species. Yeah, yeah.
Can I still have a follow-up question? I think I can. So yeah, do you need to submit it to like a kind of website, something like that? For example, in GIN we have NCBI, something like that, or do you have? Yeah.
No. When we describe it and then make a publication, we submit it in the journal, and then we have to the type. I mean, specimen as a holotype, we have to put it in a museum, I think. So if it's from Indonesia, then we have to put it in Indonesia. Then when I describe the specimen, I think from New Caledonia, then I have to submit it in Paris Museum, and if it's from Singapore, and then it will be in Natural History Museum in Singapore or something like this. Yeah.
Yeah, thank you.
Thank you all for the nice afternoon. And so Dr. Rahuyu and Paru Rossi and Dr. Davy and Dr. Black. So when I saw the research from Domain, so you work on restoration, but actually there is very much investment, and it's also with so linked with the government. So when you propose improvements, that these improvements also can be made. And that Indonesia is an enormous country, and that you are working on biodiversity and conservation, but in the more than 1,000 scientists, how many people are working in your field? And do you think there is enough interest in society that to be able, when you propose things, that they also will be executed? So I don't say it to who needs to answer, it's a general question. Yeah.
For taxonomy, morphology like myself, it's not many people like to work with this. And now the young generation, they prefer more with the molecular biology. But I think if we work together, I mean, morphology and molecular, it will be the best. But well, difficult to attract the young people to work with the taxonomy. They said we cannot earn money with it. With the taxonomy for what? So well, we'll see.
Thank you, Dr. Ma, for your question. I think now we have one ministry called the Ministry of Maritime and Investment, and this ministry is quite strong, because the minister was very close to the president, and we will have the program for maritime. This is for maritime. For example, we will have the program for maritime for 2045 is the country should based on the maritime. So we have a lot of the program based on the maritime. For example, seaweeds. Now they will make national center for seaweed, even for food, sweet, and also for energy, for example. And a lot of scholarship now in BRIN is also belong to the maritime and maritime sciences. I think in the near future we will have a lot of maritime sciences to upgrade our knowledge in maritime science and also aquaculture.
I thank you for your answer. I also wonder if Dr. Davy has an answer.
Pardon me. Sorry, I am not clear with your sound. Maybe you can write down the question and I will answer, or maybe the moderator can give me the clear question. I'm sorry, I cannot hear the clear sound from the room.
Yeah, we will try that for now.
Okay, I repeat the question. So we had
presentation by Done about the water pathways for fish. And so there is interest in society, and our society invests a lot of money because all these pathways, these are large constructions in a way, and that costs a lot of money. So there is an interest in society to help solve these problems, because this is taxpayers' money that is spent. And I wondered, in Indonesia, Indonesia is not 10 times, not 100 times, I think more than 100 times bigger than the Netherlands, and with coastline that is enormous, and with marine resources that are enormous. So what is you work, and you can propose suggestions to conserve better the environment, or to restore some species or environments to the origin. Is there an interest in society to help you with that, with your work?
Okay. If I'm not misunderstanding with your question is about the society in our activity, isn't it? Yes, in our activity, we also included the community to support our activity in the field, to monitor what we already deploy in the certain area, such as in Derawan. For the example, the cage that we already installed in that area to monitor the behavior of turtle and the restoration of seagrass ecosystem in that area. We included the community in that area to give us the what we call the some note. There could be write down what they find, what they found in the site, and then they give information to me, to us, to our team. So to get the target for our research, we also included the community in our area. Maybe that's my answer. Hopefully it could be fulfill your question. Thank you.
Sure. A large difference by the way it's organized in the Netherlands. We working with the community, is not in our task. We have other departments who are more applied and work with community, but it's certain that the interest is there if you work directly with the community. Thank you.
Okay. Thank you very much for the question and the answer from Dr. Devi. So the next question is from Dr. Zainal Arifin. The question is in the chat room. Thank you for the good presentation. I would like to ask Ms. Devi about smart aquaculture that have been implemented. What kind of smart aquaculture can be elaborated? Thank you very much. Sarah cannot ask directly because just now. Please, Bu Devi. The time
is. Yes, thank you, Ibu Moderator. Thank you, Pak Jainal. So regarding the smart aquaculture, there are two aspects that can be defined for smart aquaculture. The first is about the application of IoT to support the aquaculture system. And the second is the combining the aquaculture productivity aspect and balancing with the natural resource and such as the mangrove ecosystem. So the balance between productivity and environment could be the target. That may be my answer to the Pak Jayana question. There are two aspects that define the smart aquaculture. Thank you.
Dr. Devi. So I think we have no more questions left in Zoom meeting. What about in this room? Any other questions? Okay.
Thank you so much. I would like to ask Don Mathiasen. I was interested with your presentation. I was working on acoustic before, but I work in a open sea, not in a like a river and ocean. But the acoustic that we use is just to see the abundance of fish. And also I work on a spawning ground. Where is the spawning ground of fish? But I would like to know, maybe this is a simple question, but I would like to know, for the acoustic that you use, can these tools show us the preference? As you are working in migration of fish, so in my mind it is for spawning, maybe for breeding spawning, but usually fish migrate for spawning. In the spawning, for this acoustic, can this acoustic show us the preference habitat? Where is the fish go in what kind of habitat? Yeah, maybe also the environmental can show the fish will be in here for the spawning times like that. Thank you.
Yes, you just tackled one of my research questions. So that's actually what we are looking into, is we want to know where fish go and why they go there. And the first sign that we are now getting is that they are tended to go to certain areas. What I showed you was one species, but we're of course also tracking other species to see if they have any differences. We expect them at least to be migrating pre-spawning, so to say, because the females that we catch, especially later on in the season, we see that their stomachs are full with eggs. They literally are about to burst. So we do expect that it is spawning migration that we are observing. One of the next steps that we are planning to do is to combine this data that we are collecting now, and we have been tagging, or at least the entire project has been tagging fish over multiple years. So if we overlap all these types of data to see if we have any grounds that are popping up every year, and maybe combine that with a fish sampling post-spawning, so we can see whether we catch juveniles. And if we then bring these juveniles or larvae to species level, we might have a strong indication that these are actually habitat types that are being used to spawn. So yes, that is possible.
And also, you mentioned about this acoustic can also detect the fish species, right? As you also check the spawning ground, I mean, this acoustic only prefer only one species or many more species?
Ideally, we have one fish species that allows all the fish species to pass. Experience teaches us that that is not the case. Actually, within our group, we have one entire PhD dedicated to unraveling what factors are driving certain species to be able to pass a fish passage or not. And just the fact that it is already that you are capable of actually just putting one entire PhD to that matter shows that there is a lot of complexity to that. But in a short answer, most fish passages have been decided initially for economic important species, and in Europe that is mostly salmonids. What we are now realizing is that this does not this does not necessarily meet the requirements for all fish species. An eel, for example, swims a lot differently and is more of a weak swimmer type rather than a salmon. So they need a lot more flow slowing areas within the fish passage, whereas a salmon, it can actually make small jumps and rather big jumps as well. So if you have a fish ladder, so to say, with increments of 30 centimeters, a salmon could be able to pass, but an eel could not be. So that requires you already to redesign your fish ladder in case you want to have that also to be passing.
Right, we have time for one more final question if anyone has one.
Okay, we have some questions in online. I would like to ask Dr. Fahruzi. You said that seaweed aquaculture constraint is about seed. Is that possible to have research about tissues culture and spores seed at your institution? Please, Dr. Fahruzi.
From
Professor Lideman from Research Center of Fisheries.
Thank you, Dr. Lidman. I think you should answer this question by your own. But nevertheless, thank you very much for your question. And in our research institution now in Lombok, we don't have the facility for the laboratory for tissue culture right now, but we collaborate with the Ministry of Fisheries in Kekotong. They have already established the laboratory for tissue culture. But I really hope that you can visit our institution here in Lombok, because we have the laboratory and facility, but we don't have the people who can do, the researchers who can do this activity. And I hope that Pak Lideman can come to Lombok for doing research together with us, and we create the tissue culture for seaweed. Thank you.
Okay, thank you, everybody. I think that concludes this afternoon's session. What we'd like to do now is take a around 30-minute break. That will give us a chance to have some coffee, relax, and also view the posters that are just outside of this room. So if you do have a poster, it'd be nice if you could stand that around in the area so people may ask you questions. I think we can meet back in here at 4 o'clock. Yeah.
Okay, for the Zoom meeting, we can close the meeting, but please, Dr. Suna, I give you back because we already have a good discussion with the distinguished speaker. So after this, for the offline session, maybe we can discuss more about this, but for the Zoom meeting, we can close. So Dr. Suna, that is yours.
Thank you so much. We are about to reach the last session, but we still have some. And we would like to thank our expert here to present the expertise. And before we move to another session, I would like to greet the participant from Zoom. We would like to let you to leave, and we will send you the electronic certificate via online. Thank you so much for joining us in this event. And now, I would like to give the time to the head of National Research and Innovation Agency to give some words.
Okay, thank you very much for all the participants. I think for the first session with the symposium, I think we will close obviously, and then after this we will continue with the poster session and also laboratorium visit. So before I close this symposium, firstly I would like to thank a lot to Prof. Dr. Mark, Dr. Lisa, Pak Ari, and Pak Suprapto, and all of you and all of the speakers who has shared your knowledge, experience to share with us together here, and to all of the participants. I hope that you will have personal communication with our speaker here, especially from Wageningen University, and perhaps that we can do next research together and here in Lombok. And lastly, I hope that this is not the first and the last time you will visit us here in Lombok. I hope that you can visit us regularly every year, for example, and then we can do a visit together, Prof. and also Prof. Mark. I think, and obviously I will close this Zoom meeting and this symposium, and we will continue with the poster session and laboratory visit. Thank you.
Now we would like to send a gift to our to Wageningen University. Pak Wageningen. Professor Ari from Hendrik Genetic, please come forward. Next, Sir Suprapto from the House, please come forward. Thank you so much, everyone. We hope that by this event, we can get some idea and knowledge and also some new insight through this presentation. And now we are going to move to the next section, which is poster presentation. I would like to invite Chair Timo and Afrilia. Oh, yeah. I'm so sorry. Now we have 15 minutes for a break, for coffee break. And after that, we will continue for the poster presentation. Thank you. So you can find some drink.
Selamat sore Bapak Ibu peserta mini simposium yang hadir di ruang Zoom. Secara resmi acara hari ini sudah selesai. Izin saya akan tutup ruang Zoom ini. Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum, terima kasih banyak. Waktunya mau salat asar.
Oke Pak Akmal, terima kasih. Waalaikumsalam warahmatullahi wabarakatuh.
Ya.
Sehat-sehat ya Pak Akmal.